So let's proceed with the fourth module, which is the Linux operating system. And the first module is going to look into making a decision in choosing an operating system. And we're going to look more into the knowledge of the major OSs and the Linux distributions. The key areas we're going to focus on are going to be the differences among these three OSs and also the distribution lifecycle management. Now, as a typical user, deciding on which OS to use for your system is not a big deal. It's a lot easier for us to just pick, go with either Windows or Mac. However, if you are an institution or an organization trying to build your infrastructure, you may want to ask some questions before you decide on which shop you want your environment to have. You may want to think about maybe getting yourself a Unix certified system or a Unix like system, Microsoft OS or Mac OS. And even sometimes you may want a combination or a mixture of some of these OSs within your environment. Now, some of the questions that you may want to ask, as you're making decisions are, will the system be used as either a desktop, a server, or run on embedded devices? Whether if you're going to run more on servers, then you may want to decide on either Windows or Linux. If you're going to run on embedded devices, you may want to look into maybe Linux or Unix certified. Or if it's a desktop, you may want to think about maybe Mac or Mac OS X or Windows. So these are things that you may want to ask before you make a decision. Another part is the life expectancy of the OS. How long will this OS run for before it runs out of support or life from the vendor? All right. So for instance, when it comes to Unix world, the various distribution vendors would release an upgrade or upgrades periodically, within what we call the release cycle. So for instance, Fedora would release, let's say within every 6 months, a new version of Fedora by the Fedora, project. Another question you may also want to ask is, are there options for the vendor maintenance? Another typical example is, let's say, Canonical, who is the parent company of Ubuntu. You may have seen that once you go to their website and you try to download a version of Ubuntu, some of them may have what we call, the LTS or the long-term support. These systems or these OSs would have a subscription-based option for you to subscribe to obtain support or maintenance, from Ubuntu company, Canonical. The same thing with Red Hat and other vendors. So you want to find out, what is the maintenance cycle of the OS before you purchase. Would you, if it runs out of life, would you still have support from the vendor or not? Now, as users, we are mostly used to just having the end product of any application or software. But before we get the final version of this OS or software, they go through a whole lot of life cycle development. So software development typically will go through release phases, such as the alpha, beta, release candidate, release to manufacturing, and even live release or stable. So these are some phases that most OSs go through before they make it to you as a final user. Now, when an OS or an application is in the alpha release, it is just basically the first official phase of the software, which is being tested. And also sometimes you have an alpha version of a product coming out and then seeking for users to test them out. Typically, the application or the software is unstable at this part of the development. It may crash or it may even lose some data, and you are going to see a ton of bugs, in such an application, the alpha phase. So when the developers take some of these feedback and comment and recommendations from the testers, now they implement all these different features and fine tune the application, remove as many bugs as they can. It goes into the beta release, which is the second phase of the software development. Again, this is also a test process, where it goes through testing by people who want to understand how the application works, try to break it, and then find many bugs as they can. It is still not feature ready yet. And even at the beta phase, it is still unstable and it may still contain some bugs in it. So after the developers have applied so many of the features, recommendations and everything from testers, now they goes into release candidate. At this part, the application, has all of the features it needs, and it may make it to the final release at this, part. But I will still go through several tests again to make sure that they are the level that is ready to push into production or is made available to the manufacturers. And that comes in the next phase of the development, which is the release to manufacturing or the gold master version of the OS. Now, so once it gets to that point, and then the next phase, which is now making, to the whole public, is the live release. And this is when the OS is fully functional and ready for the public to use it. Microsoft, for instance, is well known for such announcement, when people are waiting to get the next live release of Microsoft OS. Let's cover some bits and pieces of each of these three major operating systems. And we start with Microsoft, Windows OS. Now, up until recently, Windows OS was mainly known for the desktop and the server versions. But with the advent and the proliferation of Internet of Things, where things, most OSs are now running lighter versions on embedded devices, Microsoft is now also trying to capture that market as well. So you can now find lighter versions of Windows OS running on embedded devices. An example is Raspberry Pi. Raspberry Pi is mainly known for running Linux distributions, but I think they have a Windows lighter version of that. And I think you can even find Windows running on some fridges and even on vehicles. So that is when Microsoft is now also branching or trying to capture the smaller devices as well. Another feature which is very well known within the Microsoft world is a Patch Tuesday. So the Patch Tuesday is basically, given the fact that Microsoft is a well-known, Windows OS is a well-known operating system in the world, it also has a lot of problems when it comes to security, problems, bugs and stuff like that. So it does get a lot of vulnerabilities, sometimes need to be patched. So Microsoft has this Patch Tuesday where it will release a patch for a couple or a list of vulnerabilities that has been disclosed to the public, even whether it's an old day, which is the 0 day, or X day. If you remember, we talked about open source and closed source. Microsoft is closed source. We've talked about that in our previous slides. Microsoft is very well known with maintaining its OSs for longer period of time before it ends its support for that. An example is the Windows XP, which lasted for 12 years before it ended its support. Even after that, I think it still maintained a bit of a support for companies that needed, the Windows OS to survive in their operation. Typically, Microsoft release newer versions of its desktop OS every 3 to 5 years. And don't quote me on that. That is just a range of time. Another good feature when it comes to Windows OS is backwards compatibility. Because Microsoft has a long history of being used by major organizations, and some of them may still be running older versions of Microsoft, older versions of Windows. Each time Microsoft releases a new Windows OS, it makes sure that the newer OS is still compatible with most features from the older ones or the previous ones. So companies can still have the older Windows OS and the newer, and then can still communicate and talk to each other without them needing to just brush off the entire old ones. Now, Microsoft, as a business model, is always looking for ways to tap into the market that is not performing very well. One of them is Linux enthusiasts, people who are just bent on using Linux, especially when it comes to cybersecurity. They have embedded what we call the subsystem for Linux on Windows OS, which is intended to make Windows much more attractive to Linux users or enthusiasts. And what the subsystem for Linux on Windows does is you are able to actually run Linux distribution on your Windows machine directly. So, for instance, if you have just one laptop and instead of just running a virtual machine in order for you to run, let's say, Ubuntu or Kali Linux, using the subsystem for Linux, you can actually have them directly installed on your Windows machine and then be able to interact with them through a command line or a terminal. Another operating system which is not open source is the Apple's Mac OS X, and that is one of the few operating systems that are Unix certified. All right, so that is why for those of you who may be using Mac, the structure is similar to Linux distributions such as Ubuntu, Fedora, and the likes. And Mac is mostly used for desktop. For most of you, you know Mac OS X as a desktop, operating system. Even though we have server versions of it, the biggest market for Mac OS X is in the desktop area, gearing towards the end users. New major releases come out every 18 to 24 months. And due to its graphical superiority, the Mac OS is well known when it comes to the media industry. The third open source operating system is a Linux distribution. Now, unlike Windows and Mac or the Apple OS X, where the vendor, we have only one vendor providing you the OS. So with Windows, we have Microsoft. With Mac OS X, we have Apple. So those are the vendors for each one of these operating systems. We do not have that for Linux distributions. And remember, I told you about what the distribution stands for, right? We have different kinds of vendors that provide distributions based on the Linux kernel. So example is we have OpenBSD, we have FreeBSD, we have Ubuntu, we have Fedora, we have Red Hat Enterprise Linux. These are all different kinds of vendors providing these distributions to us as users. Now, distributions can be broken into commercial and also community support based. The commercial ones, well-known ones are Oracle Solaris, IBM AIX, HP UX, Red Hat, and the likes. Those are the ones which are geared towards commercial. Most of them have the community versions of it to cater to us who don't want to pay money for these. All right. The most well-known ones are the Ubuntu, CentOS, Fedora, and then open source. The next sub-module is understanding computer hardware. And we are going to look into some of the components into building a computer, whether it's going to be for a desktop or a server. Even if you haven't built a computer before, this would also be a good way for you to understand some of the necessary components that go into computer building, whether it's a desktop or it's a server. So Linux can be found on all shapes and forms of hardwares. As I had mentioned previously, you can find Linux on Raspberry Pi, you can find it in fridges, you can find it in automobile, a whole lot of places that you can find Linux. So the distributions are built to run on specific hardwares. So most of the vehicles you see around, the infotainment or where you play your music, the touch screen, the GPS, all of them are running operating system. And most are running the Linux distribution or the kernel. Because we have so many distributors or vendors, the only way that we can have this OS running is their accompanying drivers or modules. When it comes to OS such as, let's say, Windows OS or Apple Mac OS X, those have specific vendors and they're able to build drivers and modules to go along with their OSs. But in a Linux world where we have so many distributions, the only way that we can have the OS talk to and work with other hardwares is through modules or drivers. So example is, let's say, a video card. So a video card you want to run on Ubuntu may have a different driver for when you run it on Fedora. So that is how we're able to get these Linux-based OSs to run. If you want to find out, let's say, information about any specific module, or you want to find out all the modules that are loaded when your system boots up on Linux machine, we can use the lsmod command to display such information. And the information is organized in 3 columns. The first column is going to give the name of the module. The second column is going to provide the amount of memory being used by that module. And the third one is going to have the number and the names of other modules that are running or using that particular module, because sometimes a module may have dependencies. It may have extra modules that depend on that. So the third column is what shows that. So in this example, we have this vsock as a module. It's running this size of memory, but it has 3 more modules that depend on it. So if you want to find more about which modules are loaded on your Linux machine, use the lsmod to display such information. So let's get into the physical components on what get into this hardware. And the first one to touch on is the central processing unit, or the CPU, or even the processor, or even a chip, as you may know with different name. And that is essentially the brain of the computer. So whenever you do all the calculations, you typing in and just dragging stuff around, and then things are being processed, all these things are being handled and managed by the processor or the CPU. So the CPU carries out the instructions of a computer programming by performing the basic arithmetics, logic controlling, and then also input and output operations specified by your instructions. The CPU connects to other hardware parts through the motherboard. And we'll talk about motherboard in a minute. Motherboards, what you have to understand is they're designed to work with specific types of processors. So if you have a motherboard which is designed to work with specific version of Intel, that motherboard may not work for AMD. And when you go to shop to buy any of these motherboards and CPUs, you actually have them written on the motherboard that tells you what type of processor it works with and even the version numbers. So let's continue and then get more into the processors, because you may have heard about some of these terminologies and wouldn't even understand what they mean. So you may hear something about multiprocessor. It's nothing, just a system with more than one processor. So if you have more than one processor, it's when we say multiprocessor. If we say multi-core, it's just one single processor, one single chip that contains 2 or more CPUs, 2 or more central processing units. Now, when it comes to these processors, we have 2 families or 2 types, and those are dependent on which year they came out. So we have the x86, or you may hear about 32-bit of something. That is what it stands for. The 32-bit is a system that processes 32 bits of data at a time. And then we also have 64-bit. Of course, that came later once we began to get more into using much more processing power for computers. The smart guys went back to the table and decided to beef up the processing power. So that came in the 64-bit. So you may also see the x86 underscore 64 or 64-bit. So the 64-bit processes data 64 bits at a time. So the bit number stands for how much data is processed at a time. 32-bit means we process 32 bits of data at a go. The same thing with 64-bit means we process data or bits 64-bit at a go. The good thing about 64-bit system or processors is it's backwards compatible with 32-bit processes. So 64 can process both 64-bit of data and also 32-bit. 32-bit is now the other way around. It can only process 32-bit at a time. The 32-bit or the x86 was invented by Intel in 1978. And as we got used to that, and then our demand as humans, went up on how to process information and data, there was a need for us to have much more processing power or much more data to be processed at a time. And that was when the x86_64 or the 64-bit was invented in the year 2000 by both Intel and AMD. If you are running a system, an OS that runs on 32-bit, it can have a maximum of 4 gig of RAM. But if you have 64-bit of a system, that can have more memory or more RAM. So for instance, my laptop that I'm working off right now is a 64-bit and it has 16-bit of RAM running on it. So if you want to get more information about the CPU, we can go into the directory, the proc/CPU info, or if you want to know the architecture or the family of your CPU on your system, you can use the arch on your system and then it will produce you the family number. So in this case, we are on a Fedora system. We type in the ARCH and that will produce the x86_64. Now, the flags within the CPU info are provided by the CPU features and its compatibility. So basically, the flags will tell us what are the features of the CPU and what is compatible with. So if you go all the way down here, all these are modules and information and features that are compatible with this particular family. The motherboard allocates power and also allows communication to the CPU, the RAM, and the all other computing hardware components. All right, so the motherboard handles everything. Everything is connected to the motherboard one way or the other. So one way that systems or the different hardware components are connected to this motherboard is the concept of a bus. All right, so this is how devices directly or indirectly connect to the motherboard. Of course, we can have multiple devices that connect to a system through the motherboard using the buses. All right, so that is how we connect some of these parts to the motherboard. So some of the benefits of having this bus is as follows. So we are able to share data among the peripherals connected to the system. So the peripherals connected to the system are able to share data. So for instance, a mouse or a keyboard or a monitor are able to communicate using the bus. The power supply to various peripherals connected to the system. So sometimes a USB mouse may not have its own power, but through the bus, when we connect our USB to the system, we're able to get power for the mouse to operate. The same thing with the keyboard. Now, the system clock signal is also used to synchronize the various peripherals so that the keyboard may not have its own time compared to, let's say, the motherboard or a chip or something like that. Now, when it comes to the buses, we have two types. We have the PCI and the USB. So the PCI stands for Peripheral Component Interconnect, and then the USB is Universal Serial Bus. So some of you may have used the term USB, and may not know the full meaning of that. So the USB is Universal Serial Bus. Now the peripherals such as monitors, keyboards, mouse can be connected to a system without connecting directly to the motherboard. Right now, my mouse is connected to my computer through Bluetooth. So it's not connected through the motherboard per se, but through through Bluetooth. The same thing with my with my keyboard. All right. Now the PCI bus is used for many internal devices such as sound and also network cards or the network interface. So if we want to obtain more information about the bus, we can use the command lspci command, which can be used to show the details about information about all the devices connected to the system via the PCI bus. To display the devices connected to the system through USB, we can use the lsusb command to show all the devices that are connected to the system through a USB. In a screenshot below, we are using the lspci command with a -- option to show information about the VGA controller, which is connected to this motherboard. Now, the VGA is, of course, the video display, graphical display, right? So we want to find out information about that. So once we issue this command, we have all this information being displayed here, but we are interested in a VGA compatible controller, and we have some random numbers here, but they are not just random, they have a meaning. The most important ones are these two numbers here in this square bracket. The first four numbers stands for the vendor, and then also the device for the VGA. So in this case, we have the 15AD and then column 0405. And this one will tell us which the vendor is, and then also information about the device connected to it. So let's get into the next screen and then show you what this number stands for, because we can also dig deeper into the meaning of this vendor that is connected, we're using for our VGA. So using the lspci and then this time focus more on the numbers, we are able to use the -D option to get more information that the vendor for the VGA is actually VMware. And this makes sense because I have this running on a VMware, so it's providing the VGA capability for this Ubuntu system. We can even use a -D to get more verbose information about this device. All right, so it will tell us the vendor is here and then the name of the device, the SVGA2 adapter. So this is one way for us to get detailed information of each device connected to a system through the PCI. If we want to get information about devices connected through a USB, then we can use the lsusb command to display information. In this screenshot, we're using the same command, and it's giving us all the devices that are connected to our Ubuntu system through a USB. This is a USB dongle that is normally used for wireless pen testing or wireless security assessment, because we are able to use this to inject packets. So in this case, we have this device here being listed as connected to our Ubuntu through the USB bus connection. So the computer hardware uses the BIOS to communicate between and among themselves. Now, what actually defines this data communication is a system management BIOS specification. This defines the data structure and access methods that can be used to read management information produced by the BIOS. If we want to obtain information about the BIOS, we can use the command DMI, decode, to display information about the system's underlying system management BIOS. So from this screenshot, we run it from Fedora, and we issue now this command. But of course, it can be very long, so we are just using a pipe and then using head to display only the 50th line. So RAM stores data and machine code currently being used on a computer. Now the motherboard has a slot where RAM is connected to the motherboard. If you remember from our previous slides, we talked about the two families of processors. We have the 32-bit and a 64-bit. The 32-bit can only have a maximum of 4 gig of RAM, but 64-bit can have more than that. So a system can sometimes run or low on a RAM. And to help with that, we have what we call the virtual RAM, or the swap space is created and used by the system. So the virtual RAM is a hardware drive space which is used to temporarily store the RAM data when the system is running low on memory. Now, to help the system from failing due to the low RAM, the virtual memory or the RAM is used instead. So if you're running out and you have so many processes running and they need more RAM to run, and you run it out of the physical one, the system is able to create its own virtual one and then temporarily allocate to processes so that your system don't run out or it doesn't crash. The command to help us show the amount of memory installed on your system is a free command, which I believe we have used this command before in our previous slides. By default, the free command will just display the amount of memory in a language that will make it be very hard for us to understand, right? Because this is how much RAM is installed here, and you have to do all the conversions. But if we want to have this displayed in megabyte, then we can use the -M to display that. If you want to show the RAM size in gigabyte, we can use the -G and it will show us that. So in this case, it's showing that we are using the actual 1 gig of RAM on this system, and then it has created another 1 gig of virtual RAM to help support system if it's running out of RAM. You can see that it has actually run out of RAM because the available free the free RAM is 0 right now. Okay, so that is when the swap kicks in and then begins to allocate virtual RAM to processes on a system, so it doesn't crash out. The next component in your computing is going to be disk devices. So the disk devices, or the hard drives, as most of us are used to, can be connected to a system through the motherboard, the PCI, or the USB. And this is the case because sometimes we may have an external hard drive and that may not need to be connected to the motherboard directly, and you may need just a USB cable to connect that external hard drive to the computer. Now, a hard drive can be logically divided into different chunks of spaces through partitioning, and we talked a lot about partitioning, and we'll get into that again this part of the slide, so we can reinforce the concept of dividing a hard drive into different sections. So partitions help to organize the contents of a disk, and we have some few types of partitioning. So we have the master boot record, which was the earlier versions of disk partitioning, and the tools used to manage the MBR partitions include the F disk, CF disk, and then also SF disk. And then we have the most recent ones, which is the GUI partitioning table, or the GPT. This is used on most modern systems, and the user is able to divide a disk into more partitions than the older version, which is the MBR. All right. It also allows for a larger space for partitioning, but MBR has restrictions on that. So these are some benefits of using the GPT as opposed to MBR. Some of the tools that we can use for the GUID partitioning table are G-disk, CG-disk, and also SG-disk. If you're looking for some of the well-known or tools for managing partitioning on Linux systems, the two most well-known ones are Parted and then also Gparted. And these are the ones which are used for managing either MBR or GPT hard disk partitioning. So in the screenshot provided here, we bring up the Gparted, and then which is the GUI version on how to manage a disk, and that will bring up this GUI, and it's telling us that the first hard drive, and we'll talk about these numbers here, has 20 gig of space. So in a Linux world, hard drives are stored within the dev directory. We have two different types of hard drives within the Linux system. We have the HD, which is for IDE drives, and then we have the SD, which is used for either USB, SATA, or SCSI drives. Okay, now each hard drive name is assigned a letter, which would increment from the letter A going forward. So let's walk through an example of this confusion. So let's say the first IDE hard drive, which is the HD, on a Linux system will have the letter A assigned to it. So within the dev, the first IDE hard drive would have the HD and then A assigned to it. The third SATA hard drive on a Linux machine, SATA is going to be the SD, right? We'll have the letter C because the third represents C. So we'll have the SDC here. So this is how the naming convention is done within the dev environment. And of course, if you do ls and then list the directory content of the dev, you have this information also showing. In addition to the drive names, which is either HD and SD, and then also the drive letters, whether it's A, B, C, D, the drive's partitions are also assigned numbers as well. So the first partition of the first IDE drive will have the HD A1. The second partition, now this will be number 2. Of the first, this will be A. SATA will be SD. So the second partition of the first SATA drive will be SDA2. And of course, we can use the fdisk command to view the partition information. So an example command to show such information will be this one right here, sudo the fdisk, and then using the option -L, and then the dev SDA. So this will be for the SATA first drive. And that will give us information such as the disk size and other information that you will need. All right, so as and when we advance in technology, newer ones keep coming up because the smart guys are always finding a way to make our life a lot more better. So talking about disk information, disk and the types. Now, we used to have the hard disk, which actually had a physical disk spinning within the disk itself. And now we have a newer one called the SSD, or the solid state drives. And these ones do not have the physical disk that spins within the disk itself. This one has a data stored on the microchips, making the SSD cards faster than the traditional hard drives. Now, typically, the SSD uses what we call the NAND-based flash memory, which is a non-volatile type of memory that keeps our stored data permanent even when the system is turned off. The SSD card can still function, or we can use that within the traditional hard disk interface or forms without needing to do anything major. Or we can even have the newly created forms that are meant for the SSD. So in either way, we are covered in how we have our SSD into our computers. Another device, or the disk device, that most of us are also aware of is the optical device, or some of you may know the CD drives, the DVDs, and the Blu-rays. Now, these can come into either writable or read-writable. The writable means we can write data into that. Read-writable means we can rewrite data, so often on a disk. Now, the disk can typically be mounted on a Linux system and can be found under the media directory in most of the modern systems, or we can find it within the mount directory on older Linux systems. We can use the umount or the eject commands to mount or eject these devices on a Linux machine. Now, as of right now, most of us are, of course, watching this on our monitor, and we ask ourselves, how do we get this information on our monitor? And that comes in the video display devices. All right, so these are the devices on computers that allow us to be able to have information displayed on our monitor. So one major device that we need to have that is a video card. All right, so the video card is required for Linux distributions to display information on our monitor. Without a video card, we can display information on our monitor. Now, the video display devices can be attached to the motherboard directly or through the PCI bus slots. No video card standards, so each video card comes with its own drivers to facilitate the operation of the video card. Talking about distributions versus vendors having their own OSs. Because we have so many distributions with Linux, we don't have standardizations on video cards. So in order for us to have these video cards cooperate or work with the various hardwares, we need to have their own hard drives which are built for them, installed on our systems to be able to communicate and then be able to display on our monitor. We have two types of video cables. We have the VGA, which you had seen previously with our command displaying the VMware VGA. That one comes with a 15-pin analog, and then we have the newer ones or the digital ones, which are the digital visual interface, and that has 29-pin digital cables. Both the monitor and the video card must support the same resolution in order to function properly. And if you want to find out the configuration of this, your video card and monitor, you can find that within the etc x11 xorg.conf.d directory. The final part that we need to have after building your entire computer is the power supply, because you can't have your computer running without power, all right? So computers would need some sort of power source to be able to boot up or turn on. Now, while this is not programmable, an incorrect type of power source for your computer can have a significant damage to it. So if you use a different kind of voltage against your computer and it has something different, then you may end up blowing up some of your components in your computer. And trust me, with somebody like me who has built some computers in the past, this is something that you want to pay attention to, because you may end up blowing up your shiny components just because you chose a wrong power source. So proper choice of power supply is required to ensure your computer receives the proper power voltage. Let's continue with where data is stored on Linux. And for this third sub-module, we're going to look at the various types of information and where they are stored on your Linux system. So we'll be talking about programs and configurations, processes, memory addresses, system messaging, and also login. So now, Linux system contains a ton of files which are organized in what we call the file system hierarchy standard. And we talked about this briefly in our previous slides. Now, the Linux package management software normally would help us in organizing, locating, and also managing files on Linux. The package management system is a collection of software tools that would automate this whole process for us. Whether we are installing an application, we just want to update an application or the system, we want to upgrade to a newer version or distribution, we want to configure, and if you want to remove some application from a system. These are all managed by the package management system, which is a collection of software. Now, we have two dominant package management utilities when it comes to the Linux world. We have the Debian managed package management, and then we also have the Red Hat RPM package management. Now, the software can be managed in two levels when it comes to the managing applications or software. It depends on how you want to have this handled. Do you want to go through the painful way of downloading an application and then use a low-level tool such as DPKG or RPM to install the package? Or you want to use a higher-level automation such as apt, yum, or zipper to automate the process for you? So those are the two ways you can have an application or a program installed or managed on Linux system. So if you want to install a package or manage a package within a Debian environment, you have two options. You can download the package, the specific package, and that has an extension of .deb, or you can have the same package installed for you automatically using the apt or the aptitude from the command line and that will do everything for you automatically. So the command syntax for using this the apt on a command line on a Debian system is either apt-get to run an update, for instance, or just apt update to run an update. So this is one way for you to run an update on a Debian system using the apt or aptitude command line. So these are examples of how we can use the apt command to or use the Debian package management. The first one is if we want to search for a particular package, we can use the apt-cache and then search and then the name of the package or the keyword. So let's say SSH. So just use the apt-cache and then search SSH, or FTP, use FTP. If we want to install a package on a Debian-based system without needing to download and install the package, we can just use the apt-get and then install and the name of the package, or we can just do apt and install and the name of the package. If we want to run an upgrade of all the applications on your Debian system, it's just a matter of changing this install to an upgrade. Now you see that I have the -y here. That is optional. The thing is, when you run an update, an upgrade on any Linux distribution, it will prompt you if you want to go ahead with that, right? So there's a yes or no. So you just have to type a Y or N to either proceed or to cancel. If you want to force the Y or the yes without being prompted, you can just use -y for that. That's why we have -y here. The same thing with distribution. If you want to just do an upgrade from a distribution level, this time you do have to prepare with a dist-upgrade. This would upgrade applications on a system. This will do an upgrade from the OS level to another level. So for instance, let's say you have Ubuntu 18.04 and there's a newer version of, let's say, Ubuntu 20.04. If you do the upgrade itself, it will just upgrade the applications on the distributions without doing an upgrade from 18 to 20. But if you want to do from 18 to 20, then you can use the dist-upgrade to do the OS level upgrade for you, which will change, which will upgrade your system from the 18.04 to, let's say, 20.04. If we want to remove a package, we can use the apt-remove and the name of the package to remove it. If we want to remove a package, including its configuration file, then we have to add in the purge, the --purge, to remove the package and also all the config files that came with it. If we want to obtain the list of installed packages using the low-level dpkg command, we can use that with a -l to give us the list of all the packages installed on the system. If we want to install an application, let's say we don't want to do an automated installation, we want to just do them manually, which sometimes becomes useful or becomes needed to do that, then we need to download the application, which will have an extension of .deb, and then to install, we just use the command dpkg and then -i and then the name or the path to the package, which has an extension of the .deb. Now let's get into the Red Hat part of package management. And then the one that Red Hat developed is the RPM package, which is on the lower level, but on a higher level, the Red Hat distribution or flavor uses the YAM as opposed to apt from the Ubuntu or from the Debian side. So it uses the Yellow Dog updater modified as a command line to manage or install applications. And this can be used on either CentOS or Fedora because those are based on the Red Hat flavor. The most recent versions of Fedora have replaced the YAM with DNF for managing packages, but it's still compatible with the YAM command. So if you take a look at a screenshot, we run this command from a Fedora system, and then it will just give us the usage Recall that back in our scripting, we showed how we should let our tool prompt a user for a usage. The same thing here, right? You can see that when we type in a DNP without any option, it drops us into the usage. This is the first parameter, the name of it, and then the options it wants us to use. And these are all the available options we can use with a DNF. So continue with the Red Hat. So the software package and then with the .rpm file extension is a lower level, and equivalent to the Debian, which uses the dpkg, the Red Hat distribution uses the RPM as a low level to install applications that have the .rpm extension. The graphical version of using or managing packages is a gpk-application, and that is one tool that provides a graphical interface to manage packages on a Red Hat distribution. And these are examples of how to use a yum command to manage packages, similar to how the apt is used within the Debian environment. Okay, so now let's get into processes or the Linux kernel processes. So once a system has completed the boot up process, as we had discussed previously, it will load a kernel, which is going to create a first process starting at the sbin init. Now, one concept within Linux is once a process is running, it's assigned what we call the process identifier or the PID, the process identification. And the first one assigned to the init is the number 1 because it is the first process which has been created or started once the system boots. Every other process that is created, that is going to be assigned a different number. All right. Now, each process would be assigned a new process ID as soon as it's created, and this happens incrementally. Now, the process that starts on its own is called a parent process. So in this case, this init process would always be a parent process because it is started on its own and it's assigned the first number. However, there are some processes that also do start their own process, and those will become the child process. So those are the ones that will start underneath a parent process. Now, a system can eventually reach out of the maximum number of PID value assigned to it, and this number can be updated or modified within this path right here: proc sys kernel and then a PID underscore max file. If you want to view the processes running on your Linux system, we can just use the ps3 command to show us what processes are running. PS command is used to view the processes running on your system, on your current user's shell. We can add a dash forest option to the PS command to display the parent-child relationship, which is similar to the PS3 command. Now, the PS command accepts other options to fine-tune what process information to show. An example is the PS command to show all processes. We can use a PS and then AUX or PS-EF, and that will give us information about the processes and details of them. As a root user or the super user on a Linux machine, you can view processes under other users, not the other way around. So other users with less privileges can only view processes running within their own user shell. But as a root, you can view other users' processes by using the -u and the name of that particular user. So an example here is we are using the PS command and these 3 options, and then the first 10 of the processes using the head command. And it's giving us this information, detailed information. If I want to find out a particular process that is causing a problem, if I look under the CMD, that will be a good way for me to know which command is causing such a problem. So the CMD section, the time section, the UID, and even a PID are the most important places I would look for system monitoring. Now, unlike the PS3 and then also the PS command, if we want to monitor processes in real time, we can use the top command. The top command by default will show us, will refresh our processes that are running every 2 seconds, and that will give us a real time read into what processes are doing what. It will show us the running processes, the system load, the CPU, and the memory usage. The other command line utilities such as atop or htop can also be used for the same purpose. Now, by default, the top command will sort the processes by the highest CPU usage. So this is a very good way for you to see which processes are consuming your CPU, similar to the task manager within the Windows world. Now, whilst you have your top command running, if you want to have more information or need more help, you can just type in the letter H, and that will give you more information on how to use the command. If you want to get out of the top command, just type in letter Q, and that will get you out of the top command. So the first line from the top command's output shows important summarized information, such as the system uptime. So this will tell you how long the system has been up and running, which is similar to the uptime command that you can use on the command line. If we want to find out how many users are logged in into the system, the top command would also show us how many users are logged in. And then talking about the CPU usage, the load average will show you how busy the system is. If the load average value is above 1.00, it may indicate less CPU time for processes, or the system is running into problems because it is overusing a CPU availability. So these are some key information that as you're using the top command, you may pay attention to, because the information can be a bit overwhelming. The next command, which we have used previously, is a free command. Now, this is again a command that we use to show the available and also used memory in a system. Unlike the top command, the free command shows output of the memory used at that moment. If we want to keep seeing an update as and when our memory is being used, we can use an option -S and then provide how often we want this to be refreshed. So for instance, in this example, we are using the free -S20, and this would update the memory usage every 20 seconds. All right, so now let's get into logging. So users and systems activities on Linux system can yield a ton of log types in your system. Now, these logs can be displayed in a terminal on a screen as and when they're happening, or you can have them saved into a file. Now, these logs can include the access logs, error messages, page records, and a whole bunch of other things. But for logging purposes, as a user, if you're on a Linux machine, most of the logs are happening within the var/log directory. And we've had, chance for us to look into that briefly, but we'll look into that again in the future. But basically, this is where you have most of your logs saved. Now, to prevent this space, because most of these logs do save files into disk, and we can't have that forever. So to preserve the disk space, what happens is the logs are rotated by renaming and replacing the older ones with newer ones. In the screenshot below, you can see that we're trying to display the directory of the var/log directory, and we can see we have these logs down here. Let's take a look at how the boot.log looks like. So in this screenshot, we are looking at the logs which are generated when you boot up your Linux machine, and you see these lines of code happening, going through. Well, this doesn't go into just an empty space. It's actually saved into the boot.log. So eventually, if you want to go back in and then look at all the processes or all the events that were generated within this boot.log, you can go into the var and then the log directory, and then show the, display the content of the boot.log. So let's get into demos on some of the concepts we have covered so far. So I'm currently logging into a brand new, freshly installed Fedora desktop. So I'm going to bring up the terminal. I'll head over to Activities and then come down here to Show Applications. And I do have a terminal here. So I'll click and open that. Once we have our terminal up and running, let's use the lsmod command to display information about the modules which are currently loaded within this system. So lsmod, hit enter, and let's scroll all the way up. And if you do recall, we have 3 columns from this command. The first column is the module name. So these are all the names for the modules. The second column is going to display the amount of memory used by each of these modules. So for instance, we have the TLS using this amount of memory. The third column is going to show the number and the names of other modules that depend or are running from this module, which is this particular column. So we don't have any here for the names, but we do have a number for B and EP. And if we go down here, we have this module, the amount of memory being used, the number of other modules which depend on this one, and this is the name of it. So this is how we use the lsmod to display information about the modules which are currently loaded on this Fedora machine. If we want to know which family of CPU or the architecture this machine is running, whether it's x86, which is 32-bit, or x86_64, which is 64-bit, we can just use this command and hit enter, and this will confirm that it is running 64-bit operating system of the Fedora. If we want to get information about the CPU, we can use the lscpu command like that to display information about this CPU on the system. And we can see that this is providing us much more detailed information about this CPU. If up until this part, you can see again the architecture is here and the CPU most is support. Because this is 64-bit, it supports both 32-bit and also 64-bit. If we go all the way down, we can see the flags. And the flags, as I mentioned on the slides previously, will show us the CPU features and also its compatibility. So these are all the features of the CPU. I can see hypervisor here, and we have the vendor and additional information here. We have the number of CPUs. We have 2 of them. We also know that the lspci command can be used to display all the devices that are connected to this machine. So using with the option -nn, and these are all connected through the PCI bus interface. We can see the VGA compatible controller. We can see USB controller, a multimedia, and a whole bunch of things that are connected to this device. Of course, as we did mention, these have meaning. The first numbers, as you can see, actually look the same throughout because they represent one particular vendor. And then the number, the following ones are representation of the actual device's number. So if we want more detail on, let's say, this particular device connected, let's copy that. And this will tell us that it is VMware USB 2 EHCI controller. Let's add -v for verbose. and we get additional information about this particular device connected. If there are any USB devices that you have connected to your Linux box and you want to list all of them, we can use the ls USB, and that will list all the USB interfaces or devices connected here to your device, to your Linux system. Let's also use the free command again to take a look at our memory or our RAM. So we have the total of this amount, and then this is a virtual amount assigned to this machine. We have used this and we have this available to use. You can see that we haven't tapped too much into our virtual memory or the swap, because we have enough free to be used from our physical memory. But this looks a little bit Greek to us, so let's add a -m and see this in megabyte. And in fact, let's do this in -g and see this in gigabyte. So we can see that we have, just one RAM, and we have one physical RAM, and then we are all one memory, and then we have one virtual memory assigned to this machine. We also did mention that there are two particular tools which are used for managing partitioning on Linux systems. We have the parted and then also the gparted. So I have switched over to my Ubuntu, and let's use the gparted and see how it looks like. And of course, we need to be admins to be able to access this tool or utility. So let's take a look, and this is how it looks like when you want to see your hard drives partitioning or your Linux partitions. So in this case, we have close to about 20 gig of disk assigned to our Ubuntu. And recall that we talked about the SDA, and then the first disk, and then the third partition, right? So we have the SD. That means this is the starter, type of hard disk, and then the first disk is A, and then the partition. This is a third partition. So as we had explained, and it makes sense because this happens to be the first partition, 1, 2, and 3, and that is in that order. So we can use the gparted to see our hard disk and even manage, create one, delete, and stuff like that. So this is how we can manage our disk using the gparted command. Let's also try to explore the dev directory. So cd dev, hit enter, and then let's list this. And as we had explained, the hard drives are stored within the dev directory. You scroll all the way up, these are all, and they all point to a mountain location. So we go all the way down to S, and these are our hard disk here, the SDA, the SDA1, SDA2, SDA3. So the things that we saw with the gparted can also be managed or viewed from the command line from within the dev directory. If we want more information about the SDA3, which is our main disk, let's copy that. Get more information about this particular disk. And we can see the size as well here. Now let's get into package management within the Debian. So let's say we have the gparted tool and we don't like it anymore. So we want to have that, uninstalled. So one of the features or the commands we can use will be the apt command. And then we can just use the remove command and gparted like that. Now remember that when we use just this command without using the purge, it is just going to remove this file, but it may have its configuration still intact. And you can see that we've been prompted to continue or not. And this was what I was telling you, that if we want to bypass this question or this prompt, we could have just added -y to this command at the top here, and that will bypass all these and then continue, assuming default just using yes. So if you don't want to continue, we'll just type N and then just kill it, abort. If I want to update the system, we'll just use the sudo apt and update, just like that, to run an update on this system. So this is done, and it's actually telling us that we have some things to upgrade. All right, so let's go back and this time remove the gparted completely. So we'll just use the apt remove. Let's add the purge and then have this completely removed. So we'll just do N and abort it. But let's bring back the command and then add the -y to bypass that prompt. So you can see now it's bypassing the prompt and it's going to go ahead and then have that file, that package removed. So it has been removed. What if we want to actually install this application? So we'll just do sudo apt and then install and then gparted itself, and that is installed. If we want to use the dpkg lower level command to list all the files and packages installed on the system, we'll just do dpkg and then -l to list all the packages that are installed on the system. And it's going to show us page by page the name of the package, the version installed, the architecture, whether it was AMD 64 or whatever, and then description of that package. If we want to go to the next page, we just hit a space bar on the keyboard to go through to the next page. So these are all the packages that are installed on this Linux system. If you want to get out of here, we'll just type the letter Q to get out of here. So this is one way for us to list all the packages installed on the system. If we want to run an upgrade, so we'll just do sudo apt upgrade and then pass the -y to go ahead and run an update, an upgrade without asking for a prompt, whether yes or no to proceed. So that is going to run an upgrade. It will give us a percentage completion as it's running. So we'll be aware of how long it will take. We also have the time here, timestamp here, and they're giving us all these statistical information for us. So similar to our Ubuntu, if we want to manage packages on a Red Hat flavor, such as Fedora desktop, we can either use yum or the DNF command line to install such packages or manage such packages. So for instance, if let's say we don't have Thunderbird installed and we want to have that installed on our Fedora desktop, we can use either yum or DNF for installation. So let's try yum install, and we'll see that before the installation proceeds, it will actually give us information about the package before we even continue with the installation. So you can see the difference between how things work on different flavors of Linux. On Ubuntu, which is based on the Debian flavor, there wasn't this kind of information provided to us or the breakdown of dependencies. However, on Red Hat based flavor, such as Fedora, we are being prompted and then given this information before we go ahead to decide whether we want to proceed or not. So if we type in Y for yes, that will proceed to do the installation for us. Okay, so that completes the installation using the yum command line. If we want to have the graphical front end to manage applications within Fedora system, we can use the gpk-application utility to display that. So let's execute that. And this is how it looks like. So this is where we can type in any package or application and then display more information about that application. So FTP, let's look up FTPD, for instance, and see if they have any packages that are related to FTP. So these are all the packages that can be installed from the GPK application front end utility. So let's pick up, let's say Pro FTPD. It will give us more information about this particular application and even go to the home page if we have to. Once we are ready to have this installed, we can just go to apply changes and then have this application installed on this machine. And as things are happening, we'll see the progress bar happening here. So let's say we want to search for any particular package on the Fedora system. We can use a yum command. So sudo yum and then just search and the name of the package we want to search for. So let's say we want to search for the Pro FTP. We can just type in the search criteria or the keyword, and this will go through the list of all the packages installed on this Fedora system and then look for any occurrence of Pro FTP in that package's name and then display all of them here. So these are all the packages that have Pro FTPD, FTP in the name. If we want the list of all installed packages, similar to what we did on Ubuntu, we can use the sudo rpm, the low-level command, and then -qa. And that will list all the packages that are installed on this Fedora system. Back on our Ubuntu system, let's change directory into the proc directory. And let's do a list of files in here. And these are all the list of processes that are running on this system. And we are looking for the first process. And as you recall, when the boot sequence is completed, this will be the first process and this will be the init. So these are all the process IDs that have been assigned to each of the processes that have been started on this Ubuntu system. Of course, we can change directory into each one of these process ID number to explore more. So if we change directory into the first process of 1, and if we do ls, we get more information about this particular process. All right. And of course, we have some things that needs root permission. Let's cut the CMD line and just use echo. And that will display this information to us. So this is a splash that we do see on the screen when we boot up our machine. Now let's run the ping command in the background against our local host, which is this machine. So we'll run it twice, so ping, and we'll call out our local machine, so localhost, and we are going to run this in the background. So let's dump this to the dev null, and let's use the ampersand. This is telling the system to ping this machine continuously because Linux by default doesn't stop pinging. So it will continue to ping itself and it will just take the output and put it into the bit bucket or discard it. And then the ampersand at the end of this is instructing the shell to run this command in the background. So we hit enter and that has an ID number or the process number assigned to it. Let's run it again and then see that it has new number 20. So incremental, it will keep going up like that. Okay, as and when new process is being run. So now let's open up a new terminal and actually run the top command, which is now going to give us statistics about this machine. So we can see, remember we talked about some of the 3 areas that you want to know about this machine once you run the top command is the uptime, which will tell us how long the machine has been up and running, how many users are logged in. So in this case, we only have 1 user logged in. And then the load average is decent. If it is anything above 1.00, then that means this machine is running out of CPU. This is at 0.02, so that is decent. So these are additional information you can see from the top command, the CPU percentage being used, and a whole bunch of things, the memory, the physical one, and then also the virtual memory usage. The total memory here, which is free right now, which is being used right now. And we can see some of the information up here, the PID, the process ID, the user that is running that particular process. And I'll say the command is also another important information you want to know is what command is running or linked to that PID, what percentage of CPU the process is using, what percentage of memory is also using. By default, this information is organized by the CPU usage. Of course, we can change this, we can change the order of this by anyhow we want based on these columns. So now that we have this up and running, what if we want to kill some of these ping commands that we have run, because those are running at the background and they may be consuming resources. So let's assume that we want to kill this particular ping command, which has this process ID. Whilst we're here, to kill the ping process, we'll press the letter K on our keyboard, and we can see that we now have this information being up. You can type in any process ID number here and then have that one killed. So let's go back to the first terminal and then copy this number and paste it here. So we want to kill the first ping command. And then we hit enter, and it's asking us to send PID this signal to kill it. So let's continue and then kill the other 2 ping commands. So again, whilst we are still on the top command, within top command, we'll press on the letter K to bring up this kill. So whilst here, let's go back and then pick up the second ping ID and paste that in here and hit enter. Now, this is going to be the signal kill by default, but we can change this. So this time, instead of picking up or hitting enter, which will by default use the number 15 signal, we can change that to 9 to false kill. And that will kill the second command. Let's repeat the same thing for the third one so we don't have any things running at the background. So K, and then paste this in, hit enter. You can change that default to 9 and then false kill that. So that is how we use the top command to manage processes that are running. Let's use a command, the Control C, to get out of here. Now let's also try and use the PS command, which doesn't do live update on running processes, but it's still useful in some cases. So let's use that with a dash. If we use that without any option, this is what we get. So it's only giving us 2 options, the bash, which is the terminal we are using, and then the PS command, which we just run. So it's only showing us these 2 commands that are currently running in our session, but that is not the case. If we want more details we can add -E to get more information here. So now the -E will produce additional information. And this is going to show us the PID, the terminal is running from, the time the command was run, and the command itself. The systemd, which is an init, has the ID PID number 1, as we've been talking about from our previous command, from our previous sessions. Let's go all the way down, and the most current command we had run was a PS command, and that has this process ID number assigned to it. Let's run the same PS command again, this time with the -O option to specify which columns we want to display. So let's say we want to display the PID, the time, and just the CPU usage and a command that is linked to that particular PID number. So it would only show us these columns. So the PID, the time, the CPU usage, and then the command being run. We can even sort by memory or any particular column. So in this case, let's add sort like that. And we want that by the memory percentage. So let's go back and actually add in the memory as well, like that. And that will sort out our output based on the memory usage. So the next thing we want to do is let's take a look at the log directory once again. So let's go into var and then log, and let's assume you want to review the the auth.log file. So first of all, let's do the ls-l to list the content of all the logs which are generated and saved within the log folder. And we can see that we have the boot.log here. We have the auth.log. Let's look into this. So we do let's do auth.log like that. And then we can see all the authentication-based activities or logs that have been generated by this log file. And I'm using the key, my mouse, to scroll through all of these, getting to the end of it. So we continue with the fourth sub-module, your computer on the network. And this sub-module is going to focus more on networking and how computers, including yours, do communicate either within local area network and even wide area network, or what is well known as the internet. So some of the key knowledge areas we're going to be looking at will be the internet itself, network, routers, and all the different kinds of network configurations that some of you may not be aware of and that happen behind the scenes. So for an average user or a typical user, when it comes to internet, we are mostly familiar with this setup on the right side here, where we have some computers at home. They may be servers or desktops. And then we may have some wireless devices such as our cell phones, our fridges, our streaming devices, our laptops, and things of that nature. And then for typical users, you may have a router, and this device is responsible for taking your traffic from your local area network and then route to the wide area network or the internet. For some advanced users, you may have additional devices such as switches that may actually connect to your wired systems. And then the switch is connected to a router, and the data traffic, which is coming from each one of these devices, goes through this switch, and then they are sent through over to the router and then its way to the internet. So that is the basic concept about internetworking. We've shortened that to network, but actually Network stands for internetworking, and it's essentially a group of computing devices such as these ones we have here, which are connected through a communication channel such as cable, which in this case, these are connected through cables, or wirelessly, which in this case, this laptop is connected through wireless. So that is what network or internetworking is all about. Now, in order for a computer to be able to communicate with another computer, they need to have some sort of a network configuration set up so that they can route traffic between and among themselves. The good thing is all Linux distributions come with networking tools, whether it's through the GUI or through a command line to configure the system's network interface. So there are some terminologies that we may have covered some previously, or some of you may be aware of them, but for those who may not, let's walk through some terminologies that you may have heard or maybe new to you here that you need to understand when it comes to network basics. Essentially, host is nothing but any device on a network. All right, so a laptop, a cell phone, smart TV, your Apple devices, the streaming devices that you have, fridges, all these on a network, or when it comes to networking, are referred as hosts, and they do communicate with one another on a network. Again, we had already talked about network, which is a group of computing devices that are connected through a communication channel, such as a cable or a wireless media. The internet is a global system of internetworking computing networks that use the Internet Protocol Suite to link devices worldwide. Basically, the internet is just a whole bunch of systems that are linked up to each other, and they use the TCP/IP to link up to communicate among each other. Now, Wi-Fi, most of you may be watching this video actually connected to a Wi-Fi. So wireless fidelity is just a networking technology for providing wireless high-speed internet and also network communication between devices. The router, as I showed you, can also be referred to as a gateway. So sometimes you may hear the network guys, talking about gateway. It's nothing but a router. It serves as a gateway between the local area network and then the internet or the wide area network. So the traffic from your internal infrastructure or your home network is routed through this gateway and then across to other different networks. An IP address is a unique network address identifier for each device connected to the network. And we'll go deeper into what an IP address and the importance of that. But you can think of an IP address as your house address or your home address or your apartment address, right? If somebody wants to mail you a package, they need to have a unique address which is linked to your name to deliver that package to you. So let's say UPS or USPS or FedEx, and your friend somewhere in California or somewhere in London or Beijing or South Africa or Nigeria or Ghana wants to send you something, let's say down here in the US, they need to have a unique identifier for you. All right. So in a digital sense, the IP address is what is equivalent to your home address, which is very unique to identify a specific device to receive a packet. All right. Now, when it comes to network segmentation, or when it comes to division of a network, we have a term that we call subnets. All right. So the net mask is essentially a 32-bit mask used to divide an IP address into a subnet and also a specific number of IP addresses that are available to a host. So for instance, you may have an IP address of 1.2.3.4. All right. Now, for the network side of it, or the subnet, that could be 1.2.3. And then from 1 all the way through to 255 will be available to you as a host port. So the 1.2.3 might be assigned to the subnet, and then the available IP addresses available to the host will be between 1 through 255. And the net mask or network mask is the one that makes this division possible. Network packet, as I said, is just a payload or data that is routed between devices on the internet. It's again equivalent to you receiving a package from somebody abroad or from within your region coming to you. So it's equivalent to that. The host name is a human readable name assigned to a computer. And you may have seen me, we had used this several times in some of our previous slides and demos. When we type a host name on the command line, it's able to give us a computer's name. So that is what a host name is. And I think we also talked about DNS and DHCP. The DNS is basically when we are able to translate an IP address, a domain, when a computer or a server is able to translate a domain name to an IP address for us. So for instance, Google.com may have an IP address, but we as a human beings, we don't care about that. But for us or for a computer to be able to understand, when we type in Google.com in a browser, we have a server that takes that Google.com and then translate that into an IP address so that our packet can be able to route to the destination. We also talked about DHCP, Dynamic Host Configuration Protocol. So basically, this is a server that is assigning IP addresses to systems when you connect to a network. So some of you may be working for an organization or a company, and the first time you walk into your company's network, you are provisioning a laptop, right? Well, the moment you boot up your laptop, you may not have an IP address for your laptop. So what happens is your laptop is going to reach out to the network and then broadcast and ask for an IP address. So your network would have a server called DHCP. The DHCP is configured to provision IP addresses to systems that are connected to the network that may not have an IP address. So that is a function of a DHCP server. Ethernet is just a cable which is connected from your laptop or your computer to a port on a network. So it gives you a physical connection to your network as opposed to wireless for, let's say, your devices such as your phone or your blenders and small stuff like that. The protocol is a common language used by computers to communicate or talk to each other. So that's a language that computers use to talk to each other. We are speaking right now in English. That is a protocol of communication between us as humans. All right. If you go somewhere to, let's say, China, all right, they may have Mandarin. That is a communication between the Chinese, people. So that's a common language for them. When it comes to digital world, the protocol is a common language which is used by computers to communicate or talk to each other. An IP address or TCP is a means by which two systems establish communication through what we call a three-way handshake. So let's say your computer wants to browse, you want to go to, let's say, facebook.com. Facebook.com is being run on a server. So your computer, which is going to be the host computer, and then the Facebook server is going to be the server. But for them to establish a communication, there has to be some form of a greeting or acceptance of something before they can communicate. So we call that three-way handshake. Your host computer will send what we call a SYN packet, synchronization packet, to the server, which is the host, the Facebook host, to begin to engage in communication. The server will send out SYN-ACK, synchronization acknowledgement, back to your system or your browser. And then your browser will just send ACK, an acknowledgement, back to the server. And then they can now establish a TCP IP link so that they can now communicate. So that is what we mean by the three-way handshake. The three-way handshake is a SYN-ACK, and then ACK. And then that is when these systems can now communicate and acknowledge that, okay, we're ready. Let's go ahead and send traffic back and forth. So as I said, an IP address, you can think of it as a home address or an apartment address. If you want to receive a package from a friend, from a family member, or from anywhere, let's say you go to Amazon and you place an order. we will need a unique identifier for you as a user for your packet to be delivered over to you. The same thing with the digital world. The one unique identifier, or one of them for systems over the network, is an IP address. So an IP address is a way for us to find out every single system that has a way for us to communicate with. An example of that is, you can see from the far right here, it's an example of an IP address, 172.16.254.1, and this could be a gateway. But basically, this is just a 4-octet number that is used to identify a device on a network. An IP address makes it possible for a packet to be routed over to a destination or a network, as I said. One thing you have to also understand is, and nowadays it's not too common when it comes to personal mailing system, but for most packages, when you order a packet from, let's say, Amazon, you would always have the destination address of you as a receiver, and then the source of where the package is coming from. All right, so that just in case the packet doesn't make it over to you as a destination address, we can return it to the original source of it. The same way with networking. When it comes to IP addresses, the packet would always have or contain a destination IP address and the source IP address. So let's say in the scenario that we described about you browsing to facebook.com, your device, which is browsing over to Facebook, is going to have its IP address in a packet as a source IP address, so that when the Facebook server is routing data back to wherever the request is coming from, it will have a destination to send it back to. So the source IP address will be your laptop or your desktop or whichever device you're using, your phone. The destination will be the server of facebook.com. The well-known IP address scheme that we had was IPv4. That was the only IP address system that we had. Now, over time, when much more systems became available on the internet, we began to run out of IP address spaces. So the smart guys went back to the table and designed a new IP address scheme called IPv6. So right now we have two types of IP addresses. We have IPv6 and then IPv4. The IPv6, of course, is supposed to give us more, it's supposed to give us a lot of IP address space so we don't run out easily. So when it comes to the formatting or the structure of these two, the IPv4 uses 32 bits for addressing. So an example, as I showed you here, this IPv4, the same thing here could be 192.168.10.120. So each one of them is going to be 8-bit of numbers, and you can have up to from 0 to 255 numbers. All right. The next one is a structure for IPv6, and you can see that it's not easy to remember at all. Of course, there's a way around that, to make it a lot easier for us to remember if we have to memorize an IP address. But IPv6 uses 128-bit for address system. So you can tell that that is going to be a lot of IP address space available for us to use. So to give you some clarity on the numbers, IPv6 has 4.3 billion unique IP addresses. That is a lot of IP addresses, but remember, that was okay about 20 years ago or 30 years ago because there wasn't so many devices on a network or on the internet. Now, with the advancement of computing systems and also so many Internet of Services devices now hooked up to the internet, we have now exhausted the 4.3 billion IP addresses, and that is why IPv6 came in. Now, I'm not going to even try that to even give you how much space we have for IPv6. You can do the math on your own, but this is how much of an IPv6 unique addresses that we have. So it's going to be 3.4 times 10 to the power 38. So this is infinity, basically, all right? So we can have lots and lots of IP addresses for generation to come. Now, whilst the IPv6 provides larger number of IP addresses space, the adoption of that has been very, very slow. We thought, once we came out with IPv6, we'll all just jump on it and then give each device's unique IP addresses. But that wasn't so. And one of the reasons why that adoption is slower is a concept of network address translation. So the network address translation is this case. So let me break down to you. If we look at the screenshot below here, what happens is, as a typical user, you have a router on your network and you have the internet. And then within your router, it will have an interface facing to the internal network and then an external network interface as well. So your router would typically have at least 2 IP addresses, one facing to the internet and then one facing to the internal. Now, each one of your devices would have what we call an internal IP address or the LAN IP address. Those are not routable to the internet. So if a system is somewhere here and wants to talk to this particular system, it cannot directly talk to the 10.0.0.4. It has to go through the router. So what happens here with the network access, the network address translation is your router only provides one public IP address to the internet. With a typical subnet, you can have up to 254 IP addresses assigned to devices. So let's say you have, about 200 devices on your home network. They all have unique internal IP addresses assigned to them. But your router will have only one public IP address to it. So if any system wants to communicate from the internet or to the internet, let's say this 10.0.0.5 wants to send traffic to, let's say, facebook.com. The router will take this IP address and assign it a unique port number within its NAT table. And then it will have the destination IP address and a port number of Facebook of, let's say, 1.2.3.4. And then the port number will be 443, which is HTTPS. So it will record that in the NAT table and then send the traffic over to Facebook. When Facebook is responding to this particular device's request, it is not going to have the destination of 10.0.0.5. It is going to have the destination of 17.2.3.4. All right, so when it sends it back, the router will take the device and then be able to translate that particular packet and then assign it back to this particular device, because it knows that this device requested this particular request and the port number was this unique port number. Let's say, fast forward, this device also wants to request something, the same process. Let's say it wants to go to google.com, and then the port number is going to be 443 for google.com, and let's say it's 10, it's going to be, let's say, 1.3.4. whatever. The router will take the request and then also put it in a table and then uniquely have a port number assigned to this particular device. So when Google is responding to this device's response, it will have the same public IP address and then coming to this destination. But because the router knows who sent this particular traffic, it's able to translate that from the source from google.com to a destination of this particular address. Now, this might sound a little bit complicated and confusing at first, but it's something that has helped a lot of organizations to deal with the shortage of the IPv4 address space in a public domain. All right. So another concept you would also have to understand is an IP address can be assigned to a device, manually or automatically or dynamically. So the dynamic one is a DHCP, but some sysadmins may also want to assign IP addresses to systems that they don't want the IP address to change, because one thing about DHCP is your IP address is not guaranteed for you forever. So let's say you close out from work, you went to work and you assigned, let's say, 10.1.2.5. That IP address is issued to you on a lease basis for, I think, up to 8 hours. Once you leave work and then you go back home, and then let's say somebody goes to work the next day and you don't go to work, and they need a new IP address, the DHCP server may assign your IP address to that particular person. So your IP address may not be the same when you go back to work the next day. And that is what sometimes dynamic IP addresses may not be good for servers, because servers need persistent IP address. So most of the time, a server may be assigned an IP address statically. And that is how these are the two ways that you can assign IP addresses to a system on a network. All right, so let's look at network configuration, all right, and how we get all these, because we talked about dynamic and we talked about static, but how do we configure this information on a system? So we can configure these things wirelessly or through a wire connection. So as I was saying, for instance, a desktop computer would usually connect to a network through Ethernet connection, whilst your laptop or your phone or your iPad or whatever will connect through wireless network. Now, the device's network can be configured through graphical user interface or through a configuration file. Most of the network configuration files can be found within the etc directory. So, for instance, if you are on a Debian distribution such as Ubuntu, you may find the network configuration files within the etc and then /network. If you're on a Fedora or SUSE distribution, you may find that within the etc, sysconfig, and then also network. So pay attention to that. But of course, these are changing most of the time, all right, over time. So if we take a look here, we have a screenshot of a network configuration file for a Fedora system, all right. And then if you can take a look, we have to go through the path etc, sysconfig, network scripts, and then this particular interface, ENS33. Now, as you can see from this interface, there are some few things that will just come up to you. You can see that the type is Ethernet. We don't have any proxy. Don't worry about that. And you can see that the boot protocol or the boot proto is DHCP. This means the system is assigned IP address dynamically. All right, so there is no static here. So that is one way for you to tell if a system or your Linux system is obtaining an IP address statically or dynamically. All right, so these are things that you should pay attention to if you are going to configure your network. But again, you can make modifications here and then change all these things and then assign IP addresses here. All right, so that is how you can view the network interface of a Fedora system. So now that we know where the configuration files are located, let's look at some of the network tools that we can use to provide information to us as net admins, because sometimes it may come to some point that you may be browsing or your network might be misbehaving, and you want to obtain more information as to why your traffic is not going through or you're not able to access the internet and stuff like that. So a few tools come into place. IP or ifconfig can be used to display the network configuration information. And one thing you should pay attention to though is if you take a look at this particular outcome or the output, you can see we have two interfaces. We have the ENS33, which is an interface that is actually providing you internet access or network access, because it's assigned an IP address of 192.168.14.134. So this is the IP address assigned to this particular interface. But for every system, or for that matter, Linux distribution system, there is another interface called LO, or the loopback. This is basically used by the device to send network traffic back to itself. It doesn't do any route out to the internet. It's just back to itself. And it's always have an IP address of 127.0.0.1. So this is how we can use an ifconfig to check our network connection, our network interface. We can also use the IP space address to also check our IP address information as well. This is the newer version of how to check an IP address for most Linux systems. You may even not see the ifconfig installed, but you can use the IP address to show the details of a particular interface. You can type the IP space address on its own without providing any particular interface, and it will show you all the interfaces. But if you want to show a particular interface, then you can use a show and the name of the interface, which in this case is ENS33. So the router directs traffic from source to destination, and each packet may go through different stops before it gets to its destination. So for instance, if you live somewhere in Atlanta, where I am right now, and you want to send a packet over to, let's say, somewhere in Nigeria, the packet will go through different hubs or network devices before it gets to its final destination. We can use a utility such as IP or route to show our routing table. So in this particular screenshot, we can see that we're running this from an Ubuntu server, and we're using the command route-n, and will show us the destination, the gateway, and then the net mask and the interface is using. What this is showing is basically if we are sending out traffic to the internet, which is 0.0.0.0, the gateway or the router that our packet will take to go over the internet is going to be this particular router. So, or this particular gateway. So 192.168.14.2 will be the gateway or the router. We can also use the IP route show to give the same information. Another tool that we can also use to determine if we can reach a particular host or not is a ping utility. Sometimes you're trying to browse to a website such as google.com, and for some reason it is not loading. So you want to find out, is this domain is alive? The server that is running this domain is alive or not? And one way to do that is using the ping suite to see if it is alive. If the system or the server is alive, we'll receive response back from that particular domain name showing that it is alive, and there might be something between us and that particular domain. And then once it's done, we'll get some information below here that tells us whether the packet was lost or we receive 100% delivery. In this case, there was 0 packet lost. That means the server is alive and can be reached. One thing you should be aware of is the ping suite within the Linux distribution can go on indefinitely. So you can, if you forget and then you hit a ping without providing the -C and the number of pings you want to be done, it will keep going forever until you hit Control-C. Windows is not like that. I think Windows by default will do, either 4 or 5 pings, and then it will stop. Linux doesn't do that. When you send a traffic, it will go through different hubs or different devices on the network before it gets to the final destination. We can use a trace route tool to identify the number of hubs or the number of devices that is between your traffic and then the destination. And then you'll be able to tell if a packet is being dropped somewhere on a different or a particular device. So that is how traceroute is used for determining any network problem. Well, sometimes too, let's say I have had some issues. I was running some test malware on my virtual environment, and I wanted to understand how the malware was working and how it was connecting to its outside command and control server or the C2 infrastructure. So one way for me to do that is using netstat. So netstat is one utility that you can use to display all your active network connections going out somewhere on the internet or even within your network. It is one of the best tools that I normally use to determine how many connections or what are the connections that I have from my system to other devices, because you never know who your system is talking to. With the netstat, I was able to determine that my system was connecting to a particular IP address on port 2222, and that didn't sit well with me. So I had to go further to investigate on that IP address to see what who it was registered to. So netstat is one way for you to determine what connections your system is making to the outside world and vice versa. When it comes to DNS enumeration, so we can use tools such as dig, nslookup, and host to test the functionality of a server's DNS information, or to get information more about an IP address and other DNS information that are mapped to that IP address or to that domain name. So we can see from the screenshot below here, I'm using the nslookup tool and then looking for MX is a mail server for this particular domain name called setuid.com. So what I'm asking for is give me, with this particular domain name, when somebody is sending an email to, let's say, username at setuid.com, what server is responsible for providing the mail services for this domain name? And that would display the mail servers that are associated with this particular domain name. There are several information that you can obtain here. You can obtain the A record for this domain name. You can change that to A, or you can even obtain all of it at once without providing any specific type of DNS record you're looking for. All right, so we've gone through a lot of concepts. So let's jump into some demos and see how computers talk to each other on the network. Let's begin by displaying the contents of the host file on this Ubuntu box. And that can be found at this location. So this is where you can manually even map an IP address to a domain name. And to do that, you can just go into the file itself. And here you can type in an IP address, let's say 8.8.8.8 to google.com. So what that happens is each time that you are accessing google.com, it will be mapped to this IP address. So this becomes sometimes useful when you are building your own, let's say, VPS on the internet, and you want to map an IP address of your public system, your public IP address to your domain name. So this is one way to do that. You can see that at the bottom here, we have something similar, but in a form of an IPv6 format or form. The next is, let's look at the DNS record. For a Linux machine, the DNS record can be found within the resolve.conf under the etc or the etc directory. So resolve.conf. And this is also one location. This wouldn't have much entries here, but typically if you were to be in an organization, this is where you find the list of all the DNS servers within your internal network. So in this case, this is just the loopback we talked about, right? This is the self DNS server. But if you're working in an organization where you have several DNS servers, all of them will be listed here within your resolve.conf. And of course, if you have a domain name within the organization, you may also have that specified in this file as well. So let's use a host command to look up a domain name. So we type in host, and then let's use Google as an example and hit enter. And this is how this will look like. So it's telling us that the domain name google.com has an IP address, IPv4, public IPv4 address of 74.125.136.100. And you can see we have multiple IP addresses assigned to one domain name, and that is normal and typical for especially companies such as Google, where more traffic is expected. In the same way, we have the IPv6 for google.com as well. Google.com mail is handled by this mail server. Let's try the same thing with nslookup. So this also have its own different outcome or output of IP addresses for the domain name google.com. Again, the same for IPv4, and then same structure for IPv6. But this did not produce the mail server. So if we want to specify the mail server, we have to use a type. All right. So using the type MX, we have provided the mail server for google.com. If we change that to only the A record, which is the A, that will give us only the IPv4 IP addresses for this domain name. Let's also use the dig tool and then google.com. And dig also has its own structure, well laid out like that. Of course, dig also has several options you can use to fine-tune your lookup. So I would say if you want to get more information, you just type in dig-h, and that will give you extra type of information that you can obtain. So we have the Q type, and it can be A, any, MX, and all name server. These are all the additional options we can provide with dig for a particular domain name. Let's use a ping suite to ping google.com. And this is going to go forever if we don't stop with a Control C. So we do Control C to stop it. And we sent out 11 packets and received all of them back. We did not have any loss of packet, which is what we expected. And then this is how long it took us for this ping and additional information. So let's cut this down to just 5 pings like that, and it will just auto stop once it has sent out 5 pings. So that is stopped. And again, we sent out 5 packets, we received 5 packets back, 0% loss, and it took us this time milliseconds to send this information back and forth. Let's take a look at also our system's current routing table. We can use route-n, and that will give us a routing table. So what this is saying is any packet we sent destined for the internet, which is represented by 0.0.0.0, the gateway or the router that takes our packet and routes out is 192.168.211.2. And the interface is going through is this particular interface. So let's take a closer look at what this particular interface is by using the IP config, the IF config, or just the IP address. So if we do IF config like that, it will list all the interfaces we have here. In my case, I have a Docker 0 because I have Docker installed on this system. But the main one that is doing all the traffic to the internet is this particular one right here, the ENS33. And that is assigned this IP address. And this is a net mask we talked about. So what this means is all this part is the subnet information. And this piece is what is assigned to each host. And that could be up to 255. So this all section is a subnet. And then 1 through 255 is going to be all the available IP addresses to any host. This is the loopback interface, which again doesn't do anything for internet. It is only used for the system's loopback transmission or communication. And the IP address assigned to that is 127.0.0.1. So that is it. Let's use the IP command. So IP add DR, and then let's focus more on the ENS33. And that would limit our output to only this IP address. This interface. All right, so let's also try to use traceroute. And let's see traceroute against google.com and see where our traffic go. Traceroute is not installed, so let's install that.
3,000 years later.
So now we have traceroute installed. Let's try to run the command again and see how our traffic, or what are the hops that our traffic go through to get to the destination of google.com. So now it's going through all these hops. This is the first hop, which is our first router or our first gateway that the traffic is going to go through. Now, everything else we've seen here is basically interference. There might be some firewalls or some devices in between that our traffic is being dropped. So that is what is happening here. Now, if you run this on your side, you may have a different outcome because each device will have a different route it takes for the same packet. So in your case, you may have a different internal gateway. Yours might be 10 dot something, it might be 172 dot something, or 192 dot something, and it may have a different route going to google.com. In my case, I am getting lots and lots of things being dropped here. Let's also determine how we want to find out what network connections are being made from our system to the outside world. So we can use netstat and hit enter, and that will drop everything on the screen. This is not helpful at all. We want to narrow this down to only network devices or network connections on our system. So to do that, let's use netstat and then -antp, for instance. Or let's start with just netstat-tl. And this will be for the local host loopback connections. This will be for our loopback connections for both IPv4 and then IPv6. Let's do the same thing and then add in just the letter N and see how this changes. So now that has converted our local host from just word or text to IP addresses. So now we can see that in our local host numbers. So let's change this number, this option, and now let's do ANTP, and now we'll see different kind of outcome because now we're not only doing loopback, we're doing everything. And you can see that we have our loopback connections and then also our actual system connection. And you can see we are connected to this IP address on port 80. Well, we were because it's closing. So we may have opened up a browser. But let me go ahead and open up a browser and then run this command again. And then it will tell us how many IP addresses or destination or foreign addresses that we are connected to. And let's browse to, let's say, Facebook. And let's open up another one and go to YouTube. And now let's go and rerun this command. And we can see that we have more network traffic, right? So we have established connections on Firefox on port 443. If we want to weed out and focus more on connections that we have established, we can just combine some of our previous command line skills and then just grep for only established. And that will give us only connections that we have established to the internet to a particular foreign number or foreign IP address. So the fifth module is going to be all about security and file permissions within the Linux system. And the first subsection or the sub module is going to focus on the basic security and also identifying user types in Linux. And most specifically, we are going to look at the various types of users on a Linux systems. We'll look at a root, standard account, and also system or network account. So far, we know and understand that Linux has a whole lot of files and directories. And one of the ways to protect and make sure that the right people have access to the right files is through authentication. So users need to authenticate first within a Linux system to be able to access a specific file. Unless you boot up a Linux distribution from a disk or from a portable device, and that may have a different way of access. All right. Now, we have also discussed or talked about the fact that Linux is a multi-user system. That means different users can log in simultaneously. But how does a system ensure that users don't cross paths and then be able to access other users' accounts or files? This is where permission comes in. So each user on a system, once you log in, is provided their own individualized settings, their home directories, and also other files. So on the right side here, you can see that on the screenshot, we have 3 users. We have the sysadmin, student, and then new user. All these users can simultaneously log into this system, but all of them would have their own directories, their home directories, and also the proper permission to be able to access files and folders. So again, we use the file permissions to restrict users' access to files, directories, applications, and processes. Every single user within Linux has what we call the user ID. And that normally starts from the number 1000 and above. Linux also has what we call groups. And every user within Linux belongs to some type of a group. So for instance, if you work in an organization, you may have a group for, let's say, the accounting department. And a user or users might belong to that this department and also the groups. Now, because you assign the accounting department as a specific group, they may have their own shared permissions. So only users that belong to that particular department and group would have access to such files. So let's say you have somebody in finance, the person may not need access to the accounting department. So the group will have restrictions and no finance user should be able to access any files within that group. Linux groups and members can be found within the etc/group file. Now, every single Linux user also has at least one or more group IDs, with the user ID being the default group ID. So when you create a new user within Linux, the username becomes, of course, the user's name. And they are assigned the first available group ID starting from 1000. So if let's say you create a user called Fluffy, and that was the first user created on that Linux system, the person would have, or the user would have, a user ID 1001. But at the same time, the user's name also becomes the first group ID, and that would also have its own group ID before they can join or they can be joined into other groups. So the user's name is a default group ID as well, or group membership as well. So the UID and the GID can be found within the passwd, which we have seen a lot, and then also the group files respectively within your Linux system. So let's look into the types of Linux accounts you may have. So we have 4 types of user accounts within Linux. We have the root, we have the standard users, and then we have the system, and then we have the network. Now, any new user created, the information is added to the database of users' home directory. And this information, the list of all users on every single Linux system, can be found within the passwd. However, the hashed password of each of the users can be found within the shadow file. I know it sounds a little bit much more confusing that the passwd you might think contains the passwords, but there's a reason for that, and we'll talk about that in the subsequent slides. But for now, understand that all users on a Linux systems can be found within the passwd, and the password hashes of all users can be found in this file. the shadow file. So the root user is the ultimate user or the admin on every single Linux system. The root user is the administrator, and that account is used to do everything administratively. Anything that requires administrative operations, such as creating users, adding users to a group, removing users, running an upgrade on a system, an update, removing files and services. These are all things that require an admin privilege, and the root account is the one that has all of it. Now, if you log in into a Linux system and you log in as a root, or switch over to the root account, the prompt will display the hashtag symbol in front of your terminal or your shell command or your shell prompt. Now, for security reasons, it is never advisable to actually log in into a Linux system as a root. So you always want to run an operation as a root or run it as an administrator, but not log into the system directly as a root. And that is just security hygiene. So a normal user can execute admin operations using either the SU, which stands for the substitute user, or sudo commands. You have seen me use the sudo. We are now going to break down into the distinction between these two commands and when you can and when you shouldn't be using them. So the SU command is used when the root account is enabled on a system. The SU command is used to switch from a normal user to the root user. So if you want to actually have a terminal prompt or a shell with the complete root account, then you can use the SU command and then switch over from a regular user such as Fluffy and then become a root. Now the SU command opens a new shell as a different user. That means you are now having a shell as a root. Now when the SU command is used, the root's password is prompted, not the user's. And you see the confusion here, or you see the distinction between using the SU or the sudo. So when you use the SU to switch over into the root account, then you need to have the root's password to become a root or have the root shell or terminal. The sudo command, on the other hand, is used when the root account is disabled on a system. So when we use the SU command, we only use that so we can still maintain the normal user's environment. And that is a preferred way of using this account. Is you don't want to drop into a session as a root, but you can run commands as a root or as an administrator without dropping into a new shell. So let's say you may have a user called Wabbit. All right, that user may have administrative privileges, but instead of you switching over to a root to, let's say, run an update on a system, you can still run the update command using the sudo before the apt update so that you don't have to use the root account itself, and then run that under the assumption of a sudo of a root. And that is a preferred way of using the root account. So with that said, the sudo command is the most recommended and the secure way to use the root privileges to execute administrative operations. And you have seen this in our previous demos where we're using the sudo and then every command that you want to execute under the assumption of the root account. If we want to list the sudo privileges of a user, we can use the command sudo -l and the name of the user, and then find out if that user belongs to the sudo group, because you can create a user and then assign the user the privileges of a sudo. So this file contains all the users that have the sudo privilege. In the screenshot below, we are showing you how you can switch over to become a root and have a root session. So one way to do that is a sudo space and then just dash. And then once you hit enter, you'll be prompted for the password. And this password has to be the password of the root and not the user who was logged in currently. So you're not typing in the password of sysadmin, by the password of the root user. And then once you get into a root session, as you can see, now you are at root at Ubuntu, and we have the hashtag here symbol showing that we are now logged in, or we have the session as a root user. When we use the ID command, it confirms that the UID is 0, which is always the root account, and the name, the username is root, and the GID, remember I told you that the user, by default, their GID is also their UID. So the group ID is the same as a root, and then this is also other groups that this user belongs to, which is also root. If you want to exit out of a particular session for another user, just type in exit, and then that will log you out and then drop you back into the former user that you were logged in with, which in this case is a sysadmin. You can see that because the sysadmin was the first account created, the sysadmin has the UID of 1000 and the username, of course, sysadmin, and the GID is the same as the UID. So this is by default the user's default group membership. And then after that, we're now going to have the list of other membership that this user belongs to. So these are the groups they belong to, the default, which is the sysadmin, and then this, that, and the rest are all the groups that this user belongs to. But pay attention, this user is able to do things as a sudoer because it belongs to the sudo group. So we can see that the sudo group has the ID number of 27, and that is what the user also belongs to. So this is one way to also find out if a user belongs to the sudo group. All right, so if the sudo command is not installed on the system, we can use the vsudo command and then use that to set up the sudo command as well. Now, if the current user is not root, then we have to switch over to the root account in order to set up the sudo account. By default, when we want to edit the sudo, we use vi or vim to edit it. Of course, that can be changed by using the export command and then set that to your favorite, favorite text editor. So if you prefer using, let's say, Nano, you can just use export editor and then set that to Nano, and that would allow you to edit the sudo or the vsudo using Nano. So this is an example of how the privileges or permissions are set for users. So in this case, this is a root user, and this tells us that this user has all privileges on this system. We can also specify specific privileges for an account on a Linux system, and we'll do that in some of our subsequent slides and also our demos. All right, so let's jump into some demos and then to clarify some of these concepts we have discussed so far. Okay, so in this demo, we are going to create two new users, Fluffy and then Wabbit. So to create a new user, we start with a sudo command because this is an administrative operation. So that means we need to be sudo, or we need an admin privilege. And then a command is add user, and then Fluffy is going to be the username. So once we hit enter, and then the new password has been created, so it's going to ask us for the full name. I will just hit enter and then keep going. Now, if you are doing this for, let's say, a corporate or an institution, these are things that you may want to provide information for, such as a full name. If they have a room number, you want to add that. If they have a phone number, work phone or home phone or other information. So once you've provided all this information, you can hit enter, and then it's going to ask us if the information is correct, and then we'll just say yes and hit enter. So you can see what happened was the new user was added as Fluffy, and then a new group of the user's name is Fluffy, because by default, the user's name becomes their default group membership before other additional membership is added. This is a third user we're creating, so it's actually going to be 1002 because the first user is this user, and that user has an ID number of 1000 because it was the first user that was created. We have a second user that we have created called Bunny, and that was assigned 1001. and the third user is Fluffy. So now we have Fluffy created. And then once we have that created for the group, you see that it's also creating a home directory for the user Fluffy. So this is going to have a permission and everything tied down to this particular user. Okay, so that is how we create a new user within a Linux system and when permissions are set in the course of the creation. Let's create one more user called Wabbit, and I will say Bunny Wabbit, and room 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Not applicable. Hit enter, and then yes. So now we have 2 users created. Fantastic. So the next thing is, let us try to switch account to the first new account we just created, which is the Fluffy. So to switch over to a new user from this user, who am I? And we are user. So we are now going to try to switch over to the user called Fluffy, and we will provide a password. So now we are Fluffy. So now let's try to run an update without using a sudo. So apt update like that, and we get permission denied because this our user does not belong to the sudo group. So let's exit out and let's confirm our sudo, or let's use a sudo -l. So we can see that we are now logged in. We are back in as the name this user, and that user, so the user, which is this one, may run the following commands on this system. And my user has all the permissions to run anything. So that is why we are able to use a sudo privilege to run admin operations. So to check the privileges of another user, such as Fluffy, we can use sudo and then -l and uppercase U and then the name of the user, Fluffy. And we can see that it will tell us the user, Fluffy, is not allowed to run sudo on this account. Now let's bring back our previous command, and then this will run against this user and see again what the output comes out to be. So the user, which is this user, may run this here. So this is one way for you to find out if a user has root privileges on a system. This is one way for attackers to perform post-exploitation or lateral movement on systems. When they gain access, they want to find out what level of permission they have on a system. If they have such permissions like this, that means they can do almost anything on that particular system. So let's go ahead and give full sudo access to the Fluffy user. So to do that, we'll just use sudo and then user mod like that, and then lowercase a and then uppercase G, which stands for add group. And then sudo is going to be the group we want to add the user Fluffy to. So we're going to add the user Fluffy to the sudo group using the user mod and then these options. So we hit enter, and then let's go back and check again to make sure that that user is given their privileges or not. Now we can see that the Fluffy user now has all these privileges assigned to it. We can also do the same thing by giving a specific privilege to a user. To do that in a different way, let's use the vsudo command like that. And we are going to go all the way down. So we can add the user here, and we'll give that to Wabbit. And instead of specifying all here, which will give the user all the root privileges, we only want this user to be able to run the apt command. And that apt command can be found within the user bin folder and an apt like that. So now we can do Control X and then save that. So now that we have assigned the user Wabbit a privilege, let's use the same sudo -i-l and uppercase U and then call out the name Wabbit, and then see that that user is only granted the apt command. So the next account we want to also focus on is going to be the user account. And we have done a lot of work on the past WD, so I'll not waste too much time on it. What I would like us to focus on is the structure of this content. You have seen some of these structure and you'll be wondering to yourself, what do they mean? So within the past WD file, fields are separated by columns and each one of them have their meaning to it. So the file is structured in this way: the name, the password holder of the username, the user ID, the group name, the group ID, any comment, which can be anything, and also the user's home directory, and then the shell, whether they have a shell or not. So everything here you see in this user, the pass WD, follows this sequence. So let's walk through step by step. We have this, let's say this first one for here, for instance, this is going to be the username, and then the X here is a password holder, a placeholder for the user. This is a user's ID. This is a primary group ID. This is any comment pertaining to this particular user account. It can be the username or the name of the service, which in this case is Pulse Audio Daemon. Okay, and then the next break-in is going to be the home directory. So the var run Pulse is a home directory. And then the next is a shell, whether we can log in as a user or not. In this case, this account doesn't have a shell or login because it ends with no login. Any account you find in past WD that doesn't have privileges to be able to authenticate to a system through a shell would have the no login. And this is very typical with daemon accounts or service account, which we'll talk about in the subsequent slides. So let's look at a breakdown again of what this stands for, all the field and what they stand for. So the first one, of course, is the field of the username, which is the name, and that will be the user's login name. The second field is a password, which holds the X, and the X character indicates that the encrypted password is stored in the shadow file. The user ID, again, is incremental, which is the user's unique ID, followed by the user's primary group ID, and then any comment, which may be the user's full name or any other comment you want to write about the user. And then we have a home directory, which can be the user's primary home directory. Normally, it has the user's name, and that is used to create a home directory. And then whether the user has a shell access or not. So if an account is, let's say, a daemon or service account, that will most likely have a no login and no shell. Users or regular users will typically have a bash as their shell. So originally, the Linux systems used to store the user encrypted password in the file called passwd. So this is what I said earlier about the reason why this file came out with its name. That was because in the olden days, Linux used to store both the username and the encrypted password in this file called passwd. And that was readable by everyone and make it easier for adversaries to be able to crack the password hashes easily because the file didn't have any permission set on it. It was readable by anyone. But in the modern systems, they had to move the password hashes into a separate file called shadow and only make it available or readable by users that have root privileges. So the shadow file can only be viewed by users with high privileges. Otherwise, you can only view the passwd, which is the list of all users on a Linux system, even if you don't have any high privilege. So that file also have its own structure of how things are grouped. So within the shadow file, we have the username and then column, and then the password hash itself, and then the last change, minimum, max, warning, inactive, expire, and also reserved. The screenshot here shows you an example of a password hash for the users, sysadmin, and then also student. So let's get into the next slide and then go through the fields from the shadow file. So the first field is going to be, of course, the name, which can be the person's name, such as his username. And then the next field is a password hashes or the hashed password. So you may see this as a type of the hash which was used. So we had a dollar sign and then 6 and a dollar sign, and the rest of them is all part of the hash password. The last change is the number of days from January 1, 1970, when the password was changed or modified. So the last time the password was modified. The minimum, which is the number, it can be any number, such as 5, is a minimum number of days before the user is allowed to change their password. The maximum is the number of days the user is forced to change their password. So for instance, you may have a password policy within your organization that requires users to change their password every 30 days or every 90 days. So that number will be either 90 here or 60 or 30. The 1 can also be a number. So how many days do you want to give your users before they know about their impending password expiration? Because sometimes, for some of you who work in corporations, let's say if you use Windows Outlook, when your password is about to expire, you receive a notification maybe a week or 2 weeks ahead of time. So this is equivalent to that, is how long do you want to provide a warning to your users on the Linux systems about when their password is about to expire. The next field is an inactive, which can be any number. Again, this one, let's say an example is 60. So that is the number of days after the password expires that the account is disabled. So for instance, if the password is expired, or if the password is expired, you give the account about 60 days or 90 days before the account is disabled. The last one is expire, and that is also the number of days from January 1, 1970, and the day the account will expire. So this is the form or the structure of the shadow file. When we do create a user's account, as we did for the Fluffy and then also Wabbit, the password is hashed or is transformed into a random character of strings, and we call that hash and saved within the shadow file. Now, a hash is just a cryptographic function that transforms a plain text into a random string of characters. Okay. Now, when the user tries to log into an account, what happens is when you go to your Linux system and you log in and then provide your username and your password, the system will rehash your password and then compare that string against the entries within the shadow file and then find a match. If it finds a match, then you are authenticated. If the rehash value does not match any entry and the username within the shadow file, then you are denied access. And that is how the authentication works in Linux system. Now, if we want to find out a particular user within the passwd file, we can use the grep command and then the name of the username and then against a file, and that will give us the name of the user. An example of how you can generate a password using the SHA-512 is this one below here. We combine the echo with a -n and then the password and then pipe that into the SHA-5112 to generate SHA-5112 hashes for us. So one concept which gets people a bit confused is when it comes to hashing and being able to crack a password. So what you need to understand is hashes or a hashed password cannot be reversed. So we are not able to retrieve a plain text from a hash value by reversing it. But we do crack these hashes when we come across them. And you may ask yourself, well, if we cannot reverse a hashed value or a string back to its original text, how is cracking how does password cracking work? So for a password cracking to work, what happens is we use tools such as, let's say, Hashcat or John the Ripper, and we take the hash value. In this case, an example is the password that I hash with the SHA-1 or the SHA-2 hash algorithm. And then we obtain a list of, let's say, word list. A word list is just nothing but a text file of several potential passwords. So the tool will hash every single entry of those passwords and then match them against the hash value that you have. If it matches any of those, then it's been able to identify the plain text that resulted into that particular hash value. If we want to find out users who are logged into a system, we can use the who command or just the W. So you saw me also modifying a user and adding the user to the sudo group. The command usermod is used to modify a user's account or features. An example is the sudo umod-a, or to add, and then uppercase G, and then the name of the group, and then the name of the user you want to add or assign to that particular group. So this is how you add a user to a group. We can also use the user del or to also delete an account. What happens is if you use this command alone to delete an account, it does not delete their files and directories. So those will be some sort of like an orphan files hanging around without any user account. So it is always advisable, if you want to completely delete an account or remove an account because of several reasons, such as the person may have left the organization or no longer works there or have moved to a different department or team, you may want to first of all move their files to someone else and then use the udel with an option of an R and then have a complete removal or deletion of this user from the system. So let's go on with a demo on how to practice some of these concepts we have discussed so far. So let's check the password age for the new user account we created from our previous slide, from our previous demo. So sudo, and then the command A will be chag, and then -- list, and then the name of the user is Fluffy. And we need to enter our user credential. So this is the information about that user's credential. And we can see that the last time the user's password was changed or updated was January 11, 2023. The password never expires and the password is not inactive. So that means it's active. The account expiration never expires. And then the minimum number of days before password can change is 0. So basically, we don't have much security here for this account. The only security we have here is the number of days of warning before the password expires, and that is 7 days to warn the user. So let's set the account to expire in the future, somewhere, let's say 2025. So if we want the account to expire in the future, say January 1, 2025, this will be a command to do that. So we hit enter and that is done. So if we want to check again on this user, and now we can see that the account expires in January 1, 2025. Let's say if we want to have the account also expired, we can just change the year to a past year, and that will make the account expired. So for instance, we are in 2023. If we set the expiration or we set the account's age to any date outside of today, somewhere, previous day or in a past year, that will make the account inactive. So right now, I have this account set to 2010, January 1, 2010, and I'll hit enter. And if we go back and then we try to look at the account's features again, we can see that the account expires. All right, so that is how we set an account to expire. If we want to try to, let's say, switch over to the user Fluffy, so we can use su Fluffy, and we can see that the account has expired and we're not able to log in. So that is one way for you to expire an account. In our previous slides, we talked a lot about how Linux system can be used for so many services such as web service, DHCP, DNS, and the likes. What happens is these services are run by what we call system accounts or service accounts. The service accounts are the accounts that manage these services. These accounts are not designed for user login. So they would always have the shell as no login here because they are only used for running services or daemons. So within the Linux community, if you hear somebody talking about daemon, they're referring to a service on a Linux system. The user ID typically assigned to these services is between 1 through 499. The 0, remember, is assigned to the root account. So the root would always have a 0 user ID, and then 1 through 499. 499 is assigned to a daemon or service account on a Linux system. Since they are not meant for login, system accounts do not have the login shell in a password file, which we can see here. So this is an example of a daemon running. We have a bin running, and none of these have a shell. Of course, the root account has a shell because we can log in as a root, which we are able to switch over to a root user. So one thing too is most of these system accounts or service accounts are created during the system installation. So for instance, if you want a system to run FTP service or SSH service or SSH daemon or SMTP, DHCP, DNS, web service, these are choices that you can select or they can be created at the installation process. However, there are some situations whereby after the installation, you may, as a sysadmin, create additional system accounts to run some services for you. So you may have, let's say, a custom service that needs its own service account, and then you can create those. To create a system account, you just need to add the -r to the user add and then the name of the service you want to create. So this is a syntax on how to create a new service account. Now, the service account would normally have no expiration date, and the account IDs are chosen from a range of system user IDs which are specified within the login.devs. So let's take a close look at how we can also create a service or instances whereby as a sysadmin, you may find the need to create a new service account. So in this demo, we are going to install the SSH service on this system. If we do netstat and then check and see if we have any system running on port 22 or listen on port 22, which is the port number the SSH runs, we don't see any here. So to install the SSH service, we'll just use sudo and then apt and then install open SSH-server. And that is going to install the SSH service for us, or the server on our system. Okay, so once that is done, the next step is let us start the SSH service and use a system D or the systemctl to start the SSH service. And if we want to check and see if this is actually running, we can just use the status to check the status, and that should say active and it's running. So if we do bring back the ntl, the netstat command, we should now have SSH running on port 22 for both IPv6 and then also IPv4. The next is, let us go ahead and list all services running on this system. So we can just use system ctl -t and then service. And this will list all the services running on this system. And then I'm just using the spacebar on my keyboard to go through this list. And then once we hit the end, we can just hit the Q and then get out of here. So let us try to stop the SSH service. And let us remove the SSH service. That is done. So let's say you want to install Nessus vulnerability scanner, but you want to create a service account or a daemon to run that particular application. So what we can do is to add or create that service or system account, we can just type in sudo and then add user and -- system, or we could just use the -r. Either way, they'll all work. And then -- no. Do not create a home directory. Otherwise, by default, it will create a home directory for the Nessus service. So we are creating a new user called Nessus, but this is going to be a service account and not a user account. And we are providing a -- system, or we could have used a -r to indicate that we're creating a service account or a system account. And we are also providing instructions not to create a home directory for this account. And then hit enter, and that user is being added. And you can see that by default, because we provided the -- system, it noticed or recognized this is going to be a system account or a service account. So it gave us a number between 1 and 499. So it gave us 129 as opposed to 1005 or 1004. And we did not create any home for this user. So let's clear this out and use tail to show the last entries of the past WD. And we can see, because this is a service account, it doesn't have any shell, no login. But because Wabbit is a user, Fluffy is a user, and Bunny is a user, they all have the bash shell as the as the shell option or field. If we want to cut the shadow file, and then we use tail etc and shadow, because we are not using the sudo, we are going to be prompted for permission denied. But if we add a sudo, now we are requesting this instruction as an admin, and that is able to provide us with the shadow, which contains the password hashes of the users on this system. In our previous demonstration, we did create a new user on a Linux system. However, with this particular submodule, we are going to look at some of the advanced features in creating users and also groups in a Linux system. We are going to look at the configuration files that determine some of these features when we create a new user on Linux system. So we're going to cover both the user and then also the group commands that are used to modify or manage users on a Linux system. And as we had previously talked about, the user account within Linux can be found within the passwd file, and their associated password hash can be found within the shadow file. Now, when a new user is created from a command line, these files are modified automatically. And that is why we use the tail command to confirm that the users we had created, the Fluffy and then also the Wabbit users, had modified the passwd file and also the shadow file with their password hashes. Now, depending on the type of Linux distribution, when a new user is created, it does create a new group called the user private group, or just the users as the primary group for that particular user. Now, let's start with the creation of the Linux users on a Linux machine. And the command that we use to create will determine or depend on what configuration files are used to determine the default settings when we use the user add command to create a new user. So we have seen that in a previous demo, we're able to create some users, but we also do have another command called user add. And this is a syntax: the user add, the options, and the username. Now, the user add command uses the default settings within the etc default and then the user add file for creating a new user. With a proper permission, we can actually edit this file by using the command user add -d. So let's walk through this screenshot below here. And as you can see from this screenshot, we are using the sudo because we have the sudo privilege, and the command user add -d, and then using the option -f, which is going to force the file to be updated to ensure that we give a user grace period of 30 days for them to be able to still log into an account or their account even if the password has expired. So this number can be any number. It can be based on your policy within your organization. You can maybe give your users a grace period of 15 days that once your password has expired, you need to renew or set up a new password, or the account may be disabled. So once we have that specified and then we use the command again without any other options, we can now tell that that has taken effect within this file. So this is one way for us to edit or modify this user add configuration file. So let's go through some of the default values that you may come across within the user add file. The first field is the group field, and the default one for the group is going to be, let's say, 100 as an example, which will be assigned to a new user. The next field is a home. This is where by default the user's name is set as home / the name of the user or the user's name. So for instance, in this example, if we have a user called student, their home directory will be home / user. This is what we talked about the inactivity of an account. This is basically a grace period we give a user after the password has expired before the account is disabled or made inactive. So this number again can be changed to any number: 15 days, 30 days, 60 days, or 90 days. So this is a number that you can modify. Now, pay attention that if the value is set to negative, that means the account is never going to be inactive. That means it will always remain as active. The expiration is the account expiration date, and you can see some of these are what we have seen previously when we looked up on the user's status. So the shell is, of course, the type of shell that a user is allowed or is dropped in when they log into the account. This is just an SH, or we can have this as a bash as well. Now, in case you create an account for a user and you need to have a mail for that user, the create_mail spool may be the option that is required or ensures that the user would have a directory with its own name within the var / mail where their mail can be stored and processed. So these are some of the default values that you can find within the user add file. So let's take a look at how we can actually view some of this information in detail. And if you recall, we had mentioned something about this file called login.devs. So the user add command also reads the content of this particular file, which can only be edited by a user with a root privilege. Now, this file contains all the configuration for the shadow file, for the shadow password, such as a password expiration policy, the ranges of user IDs when we create a new system, and even regular users. Recall that when we create a new user, they are assigned a value of 1000, and then incrementally as we create new users. These values are assigned or specified within this file, which you as a sysadmin can always modify that, set up the minimum or even the maximum. So on the right side, let's go through the screenshot using the grep command and then getting the content of this particular file. So the most important ones which you may pay attention to are the UID minimum, which is 1000. So this is where the number is coming from when it comes to creating a new user. We can also modify this file as well. If you have the root privilege, you can always modify this number. The maximum ID will be 60,000. So this is assuming that we can create 60,000 users on one Linux system. Again, you can modify this number. For the same thing with the group ID, the minimum is always the same as the default user ID. So 1000, and also the maximum is 60,000. The login retries is up to 5. Again, you can modify this to maybe 3 or 6 depending on your choice or your policy within your organization. And then the login timeout is 60 minutes. And then these are some of the additional things that you may also want to modify. Now, without any option provided, when we use the user add command, it will create a new user account with the default settings that we have in the user add file. So again, the syntax is just simple as just user add and then the username. That is the default, and will pull up everything defined within the user add file. However, if we want to be a much more advanced and then fine tune our creation of a user, we can add more options. So in this example, we are using the user add and then -u to specify a type of user ID we want to give our user. So we can actually create or specify manually a user ID for a user. And then the -g is going to create or assign the primary group for the user as users. By default, it would have been the user's username, but we can actually set up the default user and group we can set up a default group membership for that user using the -g option. The -g uppercase is going to be additional groups that we want to assign this user to. And then the -c is for comment, which can be maybe the user's full name. And then the last one is the actual username, which in this case is the J Smith. So the -g option has permission for the user to the test and then also the HR as supplemental groups. The user add commands would now update these 4 files: the passwd, the shadow, the group, and then also the G shadow files as a new user is created. Now, this same thing here is happening within the screenshot here. We did the same, we did that for this user, J Smith, and then we used the grep command to grep out the J Smith to confirm this account was created for against the passwd, and it shows that this user was created. And then the group ID is 1002. And then, the user ID is 1002. The group ID is just 100. And then the comment that we have provided here is the John Smith as a full name. This is the home directory. And then they have the SH as the shell option. Now, if we were to just do grep the jsmith against the group file, it will show that this user has these two supplemental groups or belong to these two supplemental groups. We can also use the same command against the G shadow, and we can confirm that user is again or belongs to the HR and the test groups. Now, unlike the add user command, which can also be used to create a new user, when we use the user add command to create a new user, a password is not prompted to be created for that particular user. So you go forward, it will go ahead to create a new user for you, but you have to go for a second step and then create a new password for that user. And the syntax is a passwd and the name of the username. You have to understand that a non-priv user can only change his or her own password, but if you are a sudoer or an account with a sudo privilege, you'll be able to update or create a new password for that particular user. So in the screenshot, we are using sudo because we belong to the sudoers group, and then passing in the passwd command, and then the name of the user we want to change their password. And then once we hit enter, we are now prompted to create a new password or update an existing password for the user jsmith. Another feature which you wouldn't see with the user add compared to the add user is the user's home directory is not created by default. Recall that when we use the add user command in our previous demo, we did not have to specify these options. These were created by default for us. But this particular command, which is the user add, the new user's home directory is not created by default. So if you look at this screenshot, we change over to the newly created user called jsmith. But once we log in, we get this prompt here saying that no directory was created by this user. So that means they are only dropped in within the shell with no display of their home directory. So with that said, we have to create a new home directory for this user. And the syntax to do that is the user add -m and then the username that we want to create a home user for. And by default, it will use the user's username to create the default home directory. If we want to create a different name, or if we don't want to use the default username's name for the home directory, we can use the -d to provide a different name. So we add the -d in combination with the -m, and then the name of the directory or the path of it, and then the user's name. And this will create a new home directory for this user with our specifications on that. In some Linux distributions, the default login shell is set to bin sh, whilst others can be in a bin bash. So we have seen that with our Ubuntu, we are using the bin bash. We can use or provide the option of -s or -- shell, and then provide a specific shell that we want the person to have when they log into a system. So for instance, the zsh is a type of shell that we can assign to a user. So to assign a shell to a user, we can just use the -s, the path of that shell, login shell, and then the name of the user, and that will provide or assign that to that particular user. To verify the user's new login shell in the passwd, we can use the grep command again, which is the grep, the username, and then the passwd, and that will show us the new login shell for this user. Now, just to recap from our previous slides and demonstrations, we talked about system or service account. Now, these are created during the creation or installation of an operating system. But using a command such as that, using an option such as -r or --system, we are able to create a new service account or system account. Again, to recap, the service account or system account do not have expiration, And all this, the random number which is assigned to the service account is between 1 through 499. And those numbers are defined within the login.defs. So we had also used the user mod to add a user to a particular group. So let's do a quick recap and then look at some of the other options that you can use with the user mod. It is essentially a command used to modify a user account. And we had used this previously in some of our demos. So if we type just the user mod -h for more help, it will give us additional information on what options we can pass in as we're using the user mod command. And if you remember, we use a -a, which is append, and then the $G for the group that we want to assign this particular user to. In the same way, we can use the user del to delete a user or remove a user from a system. And I had talked about the fact that if we use the user del on its own without any option, it will only remove the user, but their files and directories may still be in existence and may not be deleted. If we want to delete the user and all the associated files and directories, then we provide the -r to have that happen. If we want to see more options with how we can use the user del command, we can always use user del and then -h, and we'll have these additional options that we can use. So now that we have covered the Linux users account creation and also management, let's get into the Linux groups. So each user belongs to at least one group. As you saw that with the root user, the root belongs to one group, which is the root, and the root is all powerful. But regular user account or service accounts may have more than one or multiple group membership. Now, each group is identified by the real group ID or the RGID. Group accounts are essentially a collection of accounts with certain shared permissions. And we talked about the fact that you may have a department for accounting and you can create a group membership for accounting, and the group would have a shared permission for all users that belong to the accounting group. Now, group accounts are administered from the etc group file in the following form: the group's name, the password placeholder, the group ID, and then the user list. So when we use the grep command for the sysadmin against this file, these are all the list of groups that this user belongs to: the group name, the password placeholder, the GID or the group ID, and then the list of the groups that this user belongs to, or the user list. The user list of users that belong to this particular group. In this case, only one user belongs to the CD-ROM and then the sudo, and that user is just a sysadmin and a sysadmin. But for the ADM, we have both syslog and sysadmin belonging to this particular group. Now, group membership are used to control user access to files. And by default, a user's primary group owns any file created by that particular user. We can use the ID command to verify a user's primary group. So if we type in the ID -lowercase, that will give us the group ID of that user, their primary group ID. If we use the ID -uppercase G, it will provide us the list of the supplemental groups the user belongs to, or it will provide us with a list of all the users the user belongs to. We can, of course, also view information about a particular user. So if you want to check out the information about the user student, we'll just provide the ID and then the name of the account. And it will show us that the user ID, the group ID, and then the supplemental or other groups the user might belong to. If we use the ID on its own without providing any of these options, it will just dump everything for us. It will give us the user ID, the primary group membership, and then other groups that this user belongs to. Now, the root account, of course, or a user with a root privilege can add or remove a group. The command to add or manage a group is called group add or add group. These two commands can be used to create a new group or manage a group. Similar to the user add and then add user, those two commands can always be used to accomplish the same task. So in this example, we are using the command group add the same way that we can use the same command, but this time make some specifications. So this will create a new group called HR and then assign a group ID of 600. If a group is created without specifying an ID, just like the way we did this one right here, then one is assigned automatically to such a group. We can also delete a group using the group del to remove a group. We can use the user mod to also add a user to an existing group as we had used previously. Now, to add a user to an existing group, we have to first check to identify what groups the user already belongs to. We had used that previously to check on sysadmin. So one way to do that is just to use the syntax of groups and then the name of the user, and that will list all the groups this user belongs to. Now, this command for adding the sysadmin to a group called new group is this way. You see that we have talked about how we can combine options by using just one dash, or we can use dash dash for each one of the options. So that's what we're doing here. Is one way for us to create or add a user to a new group is the sudo user mod dash a for append, and then dash uppercase G for the supplemental group, the name of the group, and then the name of the user we want to add to that group. Now, we use the A option to avoid removing already existing groups that the user may belong to. Now, the group modification or the group mod command can be used to modify a group's properties as well. And if we want to change a group ownership of an existing file, we can use the chgrp. And this is a syntax in doing that. So sudo, this command, the group name, and then the file that we want this group to have control over or be applicable to. So similar to when we create a new service account or system account, the GIDs of the service account or system accounts range from 1 through 499. Now, when we change a group's GID, what happens is any files that are associated with this particular group will no longer be linked to that group anymore. And that will end up creating what we call orphan files. All right. So if we just do, remove or change a group's ID without using the dash uppercase R to recursively apply that changes, then we end up having files with no, group ID. And those are the ones we call orphan files. And if we want to find out all orphan files on a system, we can use a find command and then start from the root or the top of the file system and then dash no group, and this will find all orphan files on the system. So in this command, for instance, we are changing the group ownership of the test.dir directory and all its files and assign that to the student group. And this is the proper way of doing that. So we've talked a lot about concepts. So let's go ahead and then put some of these into practice with demonstrations. Let's create a new group called developers, sudo add group, and we provide the password of our user because we belong to the sudo group. And we've created a new group called developers, and the group ID is 1004. Let's add the user Fluffy to this new group. Sudo user mod dash a uppercase G developers, and Fluffy. And that user has been added to the developers group. And if we use a command groups and the username Fluffy, that will list the groups this user belongs to. So this user belongs to the Fluffy, which is the default group membership. It's also a sudoer, and then also belongs to the developers group. Let's use another command to display information about this particular group called developers. So let's use getEnt. And these are the information about this particular group. So the name of the group, the password placeholder, the group ID, and then the members that belong to this group. So only one so far. Now let's display the last 10 lines within the passwd. And we have these users here. Let's try to log out the account for the user Bunny. The command to do that is sudo and user mod and then dash uppercase L for login and the name of the user Bunny. And this will log out this user account. So to demonstrate how logging an account can be identified or a locked account can be identified in a Linux system, let's try to do one more login account and then walk through the process of identifying systems or user accounts that have been logged. So let's use the sudo and then tail to display the shadow file, which contains the password hashes of all the users. And you can see that because we have this user account locked, we have the exclamation mark here. And this is an indication that this account has been locked. Let's do the same thing for this account called Wabbit. We can see that before locking this account is active. So we've been able to authenticate to this account as Wabbit because this account is active. This time, let's try to log out the Wabbit account and then display the shadow file and see if anything changes. So we'll use the sudo and the user mod -L and then this time Wabbit. So now let's display the shadow file. And we can see now we have the exclamation mark again here, indicating this account has now been locked because in the previous screen, the previous Outlook, there was no exclamation mark. So let's remove the user Bunny from the system. So sudo del user -- remove home and the name of the user we want to apply this command to. And this will go ahead and then remove everything about this user. Let's confirm that this actually took effect. So let's use grep and then grep out the user Bunny from the passwd, and nothing should show up because that user no longer exists. Let's also go ahead and then delete the group that we created, the developers. So sudo del group developers, and now we have that also removed. So far, we've talked a lot about permissions on Linux system. This time, we are going to focus more on managing file permissions and ownership from this sub-module. We are going to try to understand how we can manipulate permissions and also ownership settings for a particular file or directory within Linux. So let's get into file ownership. When a user creates a file in a typical scenario on a Linux system, it has the following three types of ownership. It has the user, the group, and then also others. So each file or each directory within Linux system has these three types of ownership. The user by default is a person or the user or the account that created the file. So of course, that user becomes the owner of that particular file they created. Now, that particular user may belong to a group or the primary group. So the primary group is also assigned the ownership of that particular file. And then we have others, other users or other people who would also be provisioned a specific ownership of that particular file. So every single directory or file within Linux system has three ownership settings. Now, a file's ownership is determined by the user ID and then also the group ID that are associated with that particular file. Now, we have so many commands that we can use to manipulate the ownership of a file. We have the chown, which can be used to change the ownership of a file or directory. We have the chgrp, which can be used to change the group ownership of a file. And then we have the chmod, which can be used to change the permissions on a file. Now, if we want to get much more information about the ownership of a file, we can use the ls command with a -l and the name of the file, and that will give us much more details or the ownership of that particular file. So let's take a look at the screenshot below here, which is run against the file name newfile.txt. And in a new line, which displays the properties of this file, the username here is specified as the sysadmin. And of course, because the sysadmin is also the default group name, that is also specified here. So let's continue. We can also use the command called stat to show both the symbolic and the absolute file permission method, which are used for files. And we'll talk more on this in a later upcoming slides. And this is an example of what we mean by the symbolic and then the absolute file permissions. So there are multiple ways we can change a user's primary group. And whichever way you choose to change the group may have different impact. So let's walk through this screenshot by using the new group command and then walk through the impact it would have when we use this command on a command line. So from the screenshot, we are logged in as a user sysadmin, and we display all the groups that are in existence on the system. We use the ID command, which displays the user's UID and the group ID. On a command line, if we issue the new grp command and then the name of the group, it is going to switch over this user's primary group over to this new group. So you can see that when we issue the command and now do or call out the ID, we have the username here still as sysadmin, but the new primary group is now plug dev. So when we create a new empty file with a touch command and then the file's name of new file2, and we use the ls command -l against this file, it shows us that now the username is still sysadmin, but the group of this file is now plug dev. And when we issue out ID, we are still confirming that we belong to this group. However, this is where I was talking about the effect this command could have depending on where or when you run it. When we issue the new grp from a command line, that particular change is effective in the current session of the user. If the user closes out the terminal or exit out with an exit command, that particular group membership ceases to exist or take effect. So when we type in exit, and then now we go back, we exit out of the new group membership, the user is back to its own default membership. Now, in the event that the group membership of a file needs to be changed, now we can use the chgrp for that effect for permanency reason. Now, that would take effect in a permanent way than the new grp that we did on a command line. Only the root user has a privilege to change any file to any group for a particular file on a system. The root user can also use the change ownership or the chown command to change the file's ownership or the group ownership. Let's look at the syntax or the several ways the change ownership or the chown can be used to make such modifications. The first one is the command ch, and then we can issue the username and then the group name and then the path or the name of the file we want these changes to occur. Or we can just provide the user's name without a group name and then just the path of the file or the name of the file. Or we can have the chown and then column, which will not provide any username but just the group name. Now let's step through this screenshot and take a look at how this particular command is taking shape. So first we tried to use the start command against the new file we created. And remember that we had provided a group membership of the plug dev. So we come to the next line, and now we're using the chgrp, and then the username and the file. And then the group name and then the file's name. So once we are able to change the file's group membership to sysadmin, and we run the start command against the new file too, now we can see that the group membership has changed over to the sysadmin. So we run the ls-l against the new file.txt, and we see these are the statistics about this file. The username is sysadmin, and a sysadmin is a group name. We can use the change ownership or the chown and then change the user ownership from sysadmin to jsmith and then the name of the file. Now the next line, we try to run the command again to check the ownership, and now we can confirm that the new file's ownership has changed over to jsmith, but the group membership stays the same as sysadmin. Now let's move over to the new file too. Again, the same information that we have for sysadmin and sysadmin. And then we list the groups again, but this time we are not only changing the username, but we're changing both the username and the group as well. So we're using the sudo chown jsmith column and then the group membership or the group name for the new file too. Once we're done, we use the ls command to confirm that the username has changed over to jsmith and the group as plug dev. The same way we can do the same changes, but this time just use a dot. Another way of using the chown. So student.plug dev against the same file, and then we list the statistics, and we can show that the account has changed over to the user student and the plug dev as the group name. Now, if we want to just change the group ownership using the chown, we have two ways of accomplishing that. So we use the ls-l against a new file, and it shows that the sysadmin is a group for this file. We use the groups command to list all the groups available on this system, and then now we issue the chown and we leave this part empty. And then we provide the column and then the new group we want to assign to this new file here. And then hit enter. We do ls-l against a file, and the group has changed over to adm. If we want to try another way or the second way of using the ch-on to change a group ownership, we just provide a dot before the group name against the file, and that would also change the group to the specified group membership, which in this case is plug dev. So now that we have talked about the different kinds of ownership within Linux or for any Linux file or directory, it makes much more sense for us to look at the access controls on how access to files or directories are restricted based on permissions. And for every single file or directory within Linux, we have three types of permission sets. We have whether the user or the group or the other can read, write, or execute permission on that particular file or folder or directory. And these three types of permission sets affect the three groups of ownerships we talked about previously, whether it's a user, which is you, whether it's a group, or for others. To view the file's permission set or access permission, we can use the ls-l command, and then that will give us more details about the permissions for a particular file or directory. So as an example, we are using the ls command -l against sample, and on the far left, we have the breakdown of the permissions that affect the user, the group, and also others for this particular file called sample.txt. So we'll take some time to walk through the breakdown of what these stand for. But in a nutshell, these are grouped into the three groups of owners or ownership on any file. The first three are for the user. The next three is for the group. And the third one is for the other or anyone else accessing this file. So let's walk through the breakdown of what I just showed you in a previous slide. The first character, which in this case was a dash, is what we call the type of the item. It can be a regular file, a directory, or a link. The next 2 to 4 characters represent the user's ownership permission. So if I go back, this is the 1, 2, 3. So between 2 and 4, this is a representation of the user owner of this file. And it indicates whether the user has a read, write, and execute permission or whatever permissions the user has on that particular file. The next 5 to 7 characters, which again, if we go back, is these three, the r dash dash, represent the group ownership of that particular file or permission of that particular file, whether the group of that file has a read, no write, or no execution privilege on it. The next 8 to 10 characters, which is everyone else or others, which is these three here, r dash dash, represent the other owners of the file. So for each file or directory, these are the properties that are assigned as permission for that particular file. So let's break down how a file permission can be assigned for any directory or file on a Linux system. The first character represents whether it's a file or it's a folder or it's a link. Most of the time, you may see just a dash. That means that particular file is just a plain text file. If you see a D, then it's a directory. So the first set of 3 permission sets apply to the user of that file. So let's say we have the sample.txt. The first 3 of these permission sets read can be translated as the user has a read permission and write permission, but no execution permission. Okay, now the R, of course, stands for read, W stands for write, and then X stands for execution. In a typical scenario, if a user has all permissions set for a file, then an X will be here. That means the user has read, write, execute on that particular file. A dash means there's no permission for that particular type of permission. The next set is the group ownership. The group of that particular person or the file may have, let's say, read and write permission as well. And then we can say all other users or all others should only have read permission, no write, and no execution. So this is how we translate a file permission or a directory's permission in Linux. So the R stands for read permission, and depending on the type of file, it may have different interpretation. So if a file has an R or read permission, that means the file can be read, viewed, and also copied by that particular ownership. If this is applied to a directory, that means that particular user, whether it's a user, it's a group, or others, can only list the file's names in the directory. If a file or directory has a W, which stands for write permission, for a file, we can modify the content of the file. That means we can write into that particular file. However, we need to have a read permission on that file before we can write into it. Of course, that makes sense. We can't write to something that we cannot read. So we should have a read permission before we can have a write permission on a file. If the content or the item is a directory, then we can add, remove, and rename the files stored in the directory if we have the W permission on it. And that also has its own requirement. And that means it requires execution permission on the directory. If a file has, or if an item has an X, it stands for execution. If that item is a file, then that means we can execute or run the file as a process. An example is if we run or if we write a bash script and we want to have it executed or make it executable, we can use the X to make it executable. If the item with the X permission is a directory, that means the user group or the owner can access the directory using the cd command. So these are the three main permission sets that each file or directory or item within Linux needs to have to restrict access to such files. Now, coming back to the command line that can be used to manage these permissions, we can use the chmod to modify a file's permission. The syntax is the change the chmod, the permissions we want to set, and the name of the file. Of course, we need to have the root permission to be able to modify a file that doesn't belong to us. We have two ways of using the chmod to modify a file's permission. And we briefly touched on that in our past slides. We have the absolute and then the symbolic mode. The absolute is also referred to as a numeric. Now, for that, a file or directory permissions are represented by just 3-digit number. Each one of them represents the total permission set for the user, group, and other. So the syntax for assigning such a permission is the chmod, the 3-digit numbers, and then the name of the file. And that would apply that permission set to that file. In the symbolic way, it's a little bit complicated or a bit more involved, and it has few requirements. The permissions are represented by the owner type, whether it's going to be a user that you want to modify the permission for, a group that you want to modify the permission for, or the other. Or if you want the permission to be applied to all the group members, the three of them, just use A for all of it. And then whether you're going to add, which is a plus, the operator, you're going to remove a permission, or you are going to set a permission. So if you add a new permission, then the operator will be a plus. If you are removing a permission for, let's say, a user, a group, or other, then we use a minus. If we are setting a specific permission, then we can use the symbol equal. And then the permission type would follow, which will be read, write, execute, or no permission at all. And an example of a syntax is chmod, and in this case, we are adding executable to the group member with a G and the name of the file. So this is one way for us to update or modify a permission for a file using a symbolic mode. So this table provides a summary of the types of permission mode, both the numeric or the absolute, and then also the symbolic, and a description of what they look like. I mean, the description of each one of these. So if a file has 0, 0, 0, which is the three-digit number for a particular file, that means no permission at all for the user, the group, and then also the others. All right, and that can be represented as dash, dash, dash from the symbolic equivalent. The same thing for if a file has just one, that means it has an execute permission, and that is represented by an X. The same for write is represented by the number 2 from symbolic. If a file has number 3 for it, that means it has write and execute. If it has just a read, it would have the R with no permission for write, execute, and that will have an absolute number of 4. If a file has read and execute, it will have the R and then no permission, and then execute, and that will have an absolute number of 5. If a file has read and write only, it will have the R, W, and then no permission for execute, and that will have an absolute number of 6. If a file has all the permission, which is the write, read, and execute, it will have a symbolic value of RWX, and the absolute equivalent is going to be number 7. Now, I know for the first time, these permissions, both the absolute and then also symbolic mode, can be a bit challenging and confusing, but let's walk through a couple of examples for the absolute mode with this screenshot, and maybe that will make some sense, or you get some clarity on how to use these. And in fact, you will see that it's not even that bad once you understand how this thing works. So we create a new file using the touch command called test.txt. We use the ls command with a -l to confirm the permission set of this file, the user, and then the group. And then we have this permission here. The first item is just a dash. That means this is just a file. If it was a W, if it was a D, that means this is a directory. So the first is just telling us that this is just a plain text file. And then this is the permission we have so far. The user of this file has only read, write permission, no execute. The group of this file has the same permission as the user. It has read, write, and no execution. Anyone else or the other ownership has only read permission. So by default, this is a permission set for this particular file. Now let's find a way on how we can modify this permission set using just the numeric or the absolute mode. So we issue sudo and then chmod, and this is the number that we are using to modify this file. We have the 3-digit number, remember, that is how we specify permission using the absolute mode. We have the first number represent the permission set for the user of the file or the user owner. The number 5 represent the group owner of the file. And then the other 5 represent the group membership, the membership for the other ownership of this file. Now, how do we come about this number? Remember that if we go back to the slide, go back to this table, these are the numbers we are using. So we see that we have 7 for the user. That means the user has read, write permission, read, write, and execute permission that we are providing to the user. So back to our slide here, we are providing read, write, execute for this user. And that is why we are sending the number 7 over there. For the number 5, if we go back to our slides table, the 5 stands for read and execute. So we are giving both the group and the other ownership members we're providing them with only read and execute permission. And that is represented by the number 5. So that is why we have the 7 for the user, 5 for the owner, and then 5 for other. And then the name of the file. So once we issue that and then use ls command to check on the permission set again, we can see that the permission has now changed from our previous one or the original one. Now the user has read, write, execute, and then the group has read, no write, just execute, and then other have read, no write for write, no permission for write, and then execute as well. The same way, if we want to change the permission set again to something different, so we have the 660. Let's go back to the table and find out what 6 stands for and the 0. So 6 means read and write permission. So we are providing the user read and write permission, and then also the group read and write permission, but we are giving no permission, which is number 0, to others. So if we go back and we issue the command against this file again, and then list the permission again, now we can see that we have the read, write, no execution for the user, read, write, no execution for the group, and no permission at all for the other ownership. So this is a way for us to modify or change a file's permission using the absolute mode or the numeric mode. And we have used the same thing for number 4, and we're providing no permission for the group and no permission for the other, and we're providing only read permission to the user. So from the numeric mode or the absolute mode permission, there is one flaw that many of you may have discovered. What if you want to modify the permission for only one specific or 2 owners and not the 3 of them? Because with the absolute, the permission is set for all the 3 owner types, the user, group, and other. Unlike that, the symbolic is the other way that has much more flexibility for you to specify or provide a permission for specific user. So we can execute the command by specifying the owner type by symbol, such as the U for the user, G for group, O for other, and then A for all. And that is why we call it the symbolic mode. We can pick and choose which user that we want to apply the permission to based on a symbol. And then once we've identified which particular user, now the next thing is a mathematical operator. Whether we are going to add the permission, which will be a plus, we are going to remove a permission, which will be the dash or minus, or if we are going to set the exact permission for that group or the user, which will be an equal sign. And then, of course, the permission type of R for read, W for write, and then X for execution, or dash for nothing at all. And this is an example, as I showed in the previous the previous slide, is the chmod, and then the symbol of the owner, which in this case, this is a G for group, the mathematical operator, which in this case is adding, which is a plus, and then the type of permission, which is execution or execute. We add an execute, and then the name of the file. So let's take a closer look at another example for this particular mode. So here we are creating the touch. We're using the touch to create the test.txt. And once that is done, we are using the chmod. And first we provide the symbol or the owner we want to apply this change to. In this case, it is U for the owner of the file. We are adding an execute permission to the text file, to the text.txt file for this user, and then hit enter. Once that is completed, and then we come down here, we can see that the X has been added to this user's permission. So the same way, if we want to actually remove a permission for more than one users or owners, we can provide those as well. So in this case, you provide G for group, and then O for other, and then the mathematical operator is a dash or minus, and then the permission type, which is an R. So we are removing the read permission for the group, and then the the other owners. So once that is executed and we come down here, we can see that the group doesn't have any read because it's a dash here, and then the other has no read neither. If we want to also still fine tune and then add multiple ways of permission, we can do that with just a comma. So the first one is, again, the chmod. We are adding the read, and we're adding the write and execute permission to the user owner. Next, we are setting the read and execute to the group owner with the equal sign. Next, we are adding read permission to the other owner, which is the plus R and then O for the owner and for the other. And then, of course, we provide the file's name. And once we do that and we use ls command, we have a confirmation that our changes have applied to this file's permission. That was a lot to consume, so let's step into some demos and apply these concepts in real world. Let's begin by changing directory into the temp folder. Use ls to display the content of it. Next, we are going to create two different directories. So I will just use the make dir, and we create a new directory called test1 underscore dir, and then test2 underscore dir, like that. And ls, and we have these two directories created. The next is, let's use the touch command to create two empty files within each of these directories. So these two commands will create two empty files in their respective directories. Let's view the contents of the directories, and we have the permissions laid out here. This means it's a file. We have read, write, no execute for the user, read, write, no execute for the user, and then we have only read permission for other. Let's do the same thing for the file in the test directory too. And it has the same thing here. Now let's check the directory's permission. So -ld like that. And do the same thing for the second. And you can see that because these two are directories, this is a permission. The permission begins or starts with a D, and the user of this directory has the read, write, and execute permission. Same for the group has read, write, and execute, and others have read and execute, no write. Using this symbolic format, let's make the directory test1 private by removing the read and execute permission for the other's owner. So we type in chmod, and then we're going to use the O for other and minus for remove, and then we're removing the read and execute for this directory 1. So this is how we make this directory private, by removing read and execute for the other owner. Now let's check again to make sure this did actually work. So let's use the ls command against it, and we can see that we have removed the read, write, and everything. Basically, the other owner has no permission on this directory. Let's accomplish the same task by using the symbolic format for the second directory as well, by adding write permission for the other owner. And if we do ls-l, now the other has write permission on this folder. Using the symbolic format, let us remove the read and write permissions for the group on the test1 dir. So chmod, and then we specify this against the group. We are removing read and write permission against the test1 directory. And let's check it again. And we can see that the read, write, and execute for the user, but for the other, it doesn't have read and write, it only has execute. Let's grant all users the same read and write permission on the second folder. And this time we are using the A to apply this permission to all the 3 users. The owners, the user, group, and then the other. So we add in read and write to test2. Great. So now let's create a new file in the temp folder and name it test.txt. And let's check the permissions on this file. So ls-l and then test.txt. And these are the permission sets of this file. Let's use a stat command to verify the absolute and then also the symbolic permissions on this file. And we have these here. So now let's use the absolute or the numeric format and give everyone execution permission or the execute permission on the file we just created. So we'll just use chmod, and now we're going to provide the 3-digit numbers for this file against the text.txt. So the breakdown here is the number 7 is providing read, write, and execute for the user owner. This second 7 is providing read, write, and execute for the group owner. And then this number 5 is providing read and execute for others owner. So let's confirm this did work by using the ls command. And yes, it did work. Now, using the absolute or the numeric format, let's modify the test.txt again, the permission, to give the group user a read-only permission. So chmod, and then 7, 4, 5, and then the name of the file. And if we do ls, the group now has read only. Fantastic. So we wrap up this module with the final and the fourth sub-module, special directories and files. And we are going to look at some of the several ways that we can set special permissions on directories or files on the Linux system. And some of the key areas we'll be touching on are going to be symbolic links and also using temporary files and directories. So far, we have understood that the Linux kernel has permissions of read, write, and execute, and those are the well-known security controls used to control access to files and directories on Linux systems. However, there are some instances where permissions need to be custom tailored to specific instances. So for instance, you may have a specific file that you may want specific type of group to have access to do certain things and not everything. So in that case, you may want to set a special set of permission to allow some people or some groups or accounts to execute some functions based on what you intend for them to do. Now we can set some of these special permissions using what we call the setuid, setgid, and also sticky bit. So these are the three well-known special set of permissions we can assign on files. Now, when any one of these permissions is set on a file, any user who runs that file would assume the user ID of the actual owner of that file. So for instance, let's say we have a file called file.txt, and let's say a setuid is set on it by user root. Whoever runs that particular file is going to assume the privilege of the root user, and more will come up in the subsequent slides to dig deeper into each one of these and their differences. All users can set special permissions for the files they do own. When a setuid permission is set on a file, such as an executable, a process or a user that runs this file is granted access based on the owner of that file, which is usually the root user. So let's say we have a file executable.sh, and that file has a setuid set on it, and the owner of the file is the root user. We have a different user, Fluffy, who is just a regular user with no root permission. If this person runs this particular executable, it is not going to run under that Fluffy person's or the user's permission. It will run that file under the assumption of a root user. Now, that seems scary because, in fact, attackers have abused this particular permission set to escalate their permission from just a low user to that of a root. But it's also necessary for some files within the Linux system. For instance, the passwd. The passwd, as much as it's a file on its own that stores users on the Linux system, it is also an executable that can be used to change your password. Now, because that passwd is used to make an update or a change to the shadow file, the shadow file, as we know from a previous slides, can only be accessible by a root user. But because the passwd may have or has the setuid set on it, when we set our password, we are able to actually update the shadow file because the passwd is run under the assumption of a root user. I know this might be a little bit confusing, so let's take a look on how we can walk through a step-by-step on how this setuid functions with an example. So for instance, let's say a user is called sysadmin, and that user wants to change their password, but a sysadmin is just a regular user. The setuid is set on passwd, but when the person tries to directly access the shadow file, because the shadow file is protected from regular users, the user is not able to directly access the file. And that is the reason why we are seeing the permission denied here. But when they use the passwd and try to change their password, which will eventually update this shadow file, because the passwd is run under the assumption or the privileges of a root user, that execution is able to indirectly update the shadow file with a sysadmin's new password hashes. So that is how the setuid functions. And it has been something that attackers have used to abuse some binaries on Linux systems. So a file with a setuid set is represented by a lowercase in place of the execute permission of the user owner. With a regular file, we will typically have read, write, execute for the user if it doesn't have any setuid set. However, looking at the passwd, because we have the setuid set, the X is replaced by the letter X, indicating that both the setuid and the execute permission for the user owner is set. On the other hand, if a file has a setuid permission set but has no execute permission for the user and for the owner or the user owner on the file, then it will show an uppercase. So let's look at the distinctions again. If a setuid is set, but it includes a setuid and also the execute permission, then you will see a lowercase. However, if the setuid is only set, but the user owner has no execute permission, then we will see an uppercase S. If we want to find files that have the setuid set, we can use the find command and then the path of a directory and then the -perm. And because the setuid is on the user owner, we provide an option for -u and is equal to S. And this will find all files, -type F for all files that have the setuid set with the lowercase. If we want to create our own setuid or even remove it, we can use the chmod command to modify a setuid permission, either using the symbolic or the numeric method. So a syntax to use the setuid symbolically could be the chmod and then the u, because remember, the setuid only affects the user owner permission, and then +s, and then the name of the file we want to set the setuid on. If we want to do the same thing but using the numeric method, we have to add the 4000 to the actual permission we're trying to set. Remember, when a permission has 7, it means it has the read, write, and execute. And this is the first permission for the user, the group, and the other. So to add a setuid, we'll just add in 4000 to this number. So it will end up being 4775 to enable setuid. In the same way, if we want to remove a setuid for a file, we just replace the mathematical operator with a minus and that will remove it. The same way, we'll replace the 4 with a 0 and that will remove the setuid. Now let's get into the setgid. And as the name suggests, it is the same or is similar to the setuid with the exception of the fact that it applies to the group owner permission. However, unlike the setuid bit, the setgid bit can be set on both files and directories. The setuid is set on only files, but the setgid is set on both files and directories. And an example is the user bin mail, which has the setgid permission set on it. Now, when a file that has a setgid bit is set and is executed, it runs with the group owner permission of that file instead of the person who is running that particular file. So let's say you have a directory which is owned by the accounting department group or the accounting group, and you belong to finance, and the accounting group has a setuid set on it. Even though you belong to the finance group, when you run or do anything under the accounting group, it will run under the assumption of the accounting group's permission. So a file with a setgid set is represented by the lowercase s in place of the executable bit on the group owner. Let's take a look at how that one looks like for the mail. So with the US bin mail that we're trying to look at its statistics or its properties, we can see that there's a lowercase in place of the X for the group owner. Now, a file that has the setgid permission set but no executable privilege for the group owner would have the uppercase set instead. So it is the same as the setuid. Now, to find all files or directories that have the setgid set, we just replace the U with just a G because the setgid applies to only the group owner permission. The setgid permission is usually set on directories to foster the sharing among groups, as I was explaining, between, let's say, accounting group and then also the finance group. Now, any file created within a directory with a setgid set would automatically be owned by the group. So let's say the finance department, Fluffy belongs to the finance department, and we have a setgid set on, let's say, the accounting group. If Fluffy creates a file within the accounting group, it is going to have the group ownership of the accounting and not Fluffy's group. Similar to the setuid, we can use the chmod to modify a setgid. So we'll just replace the U with just a G here, and then replace the 4 with 2000. And the same way, if we want to remove, we'll just use the mathematical operator -s to remove it, and then also 0 to remove the setgid. So we use the chmod and then G plus S on the directory called test. And then once we do the list directory, we can see that the executive or the execute has changed to the letter S for this directory. Of course, we know this is a directory because it begins with a D, indicating a directory. So we are logging to the system as the student user, and we use the ls command to list the properties of this directory that has the setgid enabled. And as you can see, the group membership of this directory is sysadmin. In the next line, we use the ID to indicate that we are student and our GID is this number, and we are the primary group for this user is student. So this user does not belong to the sysadmin group. However, the person is able to create a new file called test.txt within the test folder, which has the setgid set. So in the next line, we try to list this particular file to check out who is now the owner of this file. And as you can see, the file inherits the permission of the test directory and then assigns it the group owner of sysadmin, even though the user belongs to the student group and doesn't belong to the sysadmin, because the setgid is set on the test folder, and every file created under that folder is going to inherit the primary owner or the group owner. That ownership is applied to this student's new file and not the student group. So the third permission that is also very much important, and I think it's a good way to avoid the inappropriate deletion of a file, is called the sticky bit. So the sticky bit is a permission that is set to protect files within a shared directory from being inappropriately deleted by other users. And I think it's a good way for us to prevent a file from being deleted by someone who doesn't own it. So if a directory has the sticky bit set, a file can be deleted only by the owner of that file or the root user, because the root can't do anything or has the administrative permission on all Linux systems. Now, this prevents a user from deleting other users' files from public directories such as the temp folder. The sticky bit is identified by the letter T, which replaces the execute permission on the other owner permission. So you can see that each one of these three special permissions are targeting specific type of ownership. The setuid is only for the user owner. The setgid is for the group owner, and then the sticky bit is set on the other owner permission. So a lowercase t implies both the sticky bit and the execute permissions are set for the other's owner. And that is for the lowercase. If we see an uppercase set, sticky bit set on the on a file or a directory, that means no execute permission is enabled for the other owner. If only the user owner has the execute permission, then the sticky bit permission would have the uppercase T at the end of it. Similar to the setuid and setgid, we can use a find command to find all files that have the sticky bit enabled, and the number for the sticky bit is 1000. So to reiterate, for the setuid, the number is 4000, for the setgid is 2000, and for the sticky bit is 1000. And that is one way for us to find directories that have sticky bit enabled. So we can also use the chmod to modify this sticky bit on permission on files, both symbolically or numerically. So in this screenshot, we use the ls command to list the test directory, and these are the information for these two subdirectories in here. We have the sysadmin, and then the root also as its own directory. So we decide to apply a sticky bit to the test directory by using the chmod and then 1 and then 775 for the owner, the owner, group, and other permissions. And then once we list that, we can see that now the T is appended to the sysadmin directory. It did not apply to this because we don't have permission over the root. So it only applied that to the sysadmin directory. So let's also continue with another concept within the Linux system called links. And now some of you may associate this to a shortcut on Windows operating system. A link in a Linux system is a pointer pointing to a file or a directory. A link serves as a shortcut to an existing file or directory, making it convenient to access a file with a long directory path through a shortcut. We have two types of these links, and depending on which one you use, it will have different impact. We have the soft link or the symbolic links, and then we also have the hard links. Now, these links behave differently depending on how they are implemented or depending on how files are moved or removed. The symbolic links are not updated when a target link file is removed or has been moved to a different location. On the other hand, the hard links always refer to the source file even if it is removed or is moved to a different location. So let's look into the hard links. So when a file is created in a Linux system, the file's meta information, such as the permission, the ownership, the timestamp, and the pointers are stored in a table called inode table. The meta information does not, on the other hand, though, include the file's name or its content. Each inode table has a unique inode number, which can be found with the ls space -i. So in the screenshot, we're using the ls space -i to show all the files in here, and this is what we call the inode number. Now the hard links point to the same inode number regardless, and we cannot create a hard link on a directory. Now, if the original file is removed, the hard link will still show the content of the original file. So every file on Linux system at least has one link, which is the original file name. The command ls and then li can be used to identify the number of links for a file. Sometimes a file may have several pointers pointing to it. If we want to know how many links are created for a particular file, we can use the ls and then the space -li to get the number of pointers. So we can see that these files all have only one links. And as I was saying, every single file on Linux has at least one link, which is the original file. So these are all the original file. If we use the command ln to create a new or remove a link, then we'll be able to either increase or decrease this number. So in this example, the syntax on creating or removing a link is ln, the original file name, and then the link name. So we are using the command ln, and then this is the original file name. You can see that we actually had it up here. It's called test.txt. And then this is the link that we are pointing it over to. So once we're done, and then we do ls with the li, now we can see that this has, the link number has increased. A soft link is similar to the file shortcut feature, which is used on a Windows operating system. A soft link, which is also a symbolic link, is a file that points to another file. So a soft link contains the path to the original file and not the content, which is a reverse of how the hard link works. So removing soft link does not have any effect on the original file. However, when the original file is removed, then the soft link will point to a non-existent file, which means it's dangling. Because this is pointing to an actual file, if we remove the file from the Linux system, it is going to end up pointing to nothing. That is what this means. So a file with a soft link will have the letter L at the beginning of the file's permission. Remember that we talked about the fact that when we use the ls to look at the properties of a file, the first character will determine whether it's a file, it's a directory, or it's a link. So when you see an L for the file, that means it has a soft link. So this syntax ls-lr can be used to recursively list all files with symbolic link in the specified directory and only display the first 10 results using the head command, or typing the results to the head command. So we're looking at this example, and we are using the ls command against the etc and using the uppercase R to recursively go through this entire directory and then grep out and then just give us the files that begin with an L and then show us only the top 10 files. We have an arrow showing as a pointer. So the local time points to this entire path. So if this path was to be removed, then this will point to nothing, just an empty space or dangling place, right? So a soft link can also link to a directory. And if we want to create a new soft link, we just provide a -s as an option with the ln command to create a soft link. Now, unlike the hard link, creating a soft link does not increase the number of links for the existing file. So let's take a look at a screenshot that we have here. So we know that the passwd is an executable which can be used to create or change a password, or it also contains the list of users within the Linux system. So we are using the ln-s as an option, and we are providing the path to the file that we are interested in. And then this is our own file that we have created called mypasswd. And we are pointing this file to our own file. So once we use that command and we try to use the ls-l against our file, we can see that this file is now pointing to passwd from within the etc folder. So each time we execute or run this file, it is going to call out this file from this path and show us the content of this file instead. So this is some concept that we have covered so far. Let us go ahead and then try to do some demos to put this into actual practice. So let's issue pwd to confirm our location. We are in the temp folder. Let's use a cd and a tilde to drop into our home directory. So we do pwd and we are within our own home directory. So let's use the command touch to create a new file called link test. And let's use the ls command to show that the file has been created. So we have that created here. Next, let's open this file and just enter in any random text and then close it. So with that created, let's go ahead and then view the details and the inward information of this file. So we use ls space -l-i and then the name of this file. And we can see the inode number here. And so far, it has only one link. We can see the number 1 here. Let's create a hard link. So ln, and then the original link's name, the original file is this one right here, link test, and the name of the link we're trying to create. So let's call it linktest.hard. So that is created. Now let's try to view the details and the inode information again of this file. So let's bring back the command. And we can see that the inode number remains the same as we had stated from our slides. However, the link numbers have increased to 2 now. Let's use the same command and create another link from the original link and then call it hard2. like that. Let's view the details again, and the inode number remains the same, but the link number has increased to 3. Let's remove the second or the third link. So rm2 like this. And let's link the list again. Let's list the links again. And we have seen that the links number have reduced down to 2 now, but yet the inode number remains the same. Let's remove the last link, and that should remove everything. Now we should have no links for this file. We should just have 1, which is the default link number. We're back to 1. Let's also try to create a symbolic link to the link test file. So that would be ln-s for symbolic or soft link. And we call it link.soft. Let's view the details. And then both the files have different inode numbers. The file's permission starts with the letter L. So this is a link. It starts with an L. And then there is the directional arrow pointing the link, the sync link file, which is the link test.soft, to the original file, which is the link test. So that is the difference, or these are some differences you see with these two types of links. So let's remove this link to finish up with this demo. There it is. That brings us to the end of this course, the Introduction to Linux. I hope you did enjoy it and also picked up 1 or 2 things from this course. If at any point in time the concept we discussed and the demos we had did not make sense to you, practice makes perfect. I would encourage you to keep going back, review the videos, and keep practicing. I know we'll definitely cross paths again in the future. Thank you for watching and have a nice day.